reduced to its underlying biological processes. And this leads to the idea of biological naturalism, an idea that Arnold Sess is currently championing. You'll see him giving a virtual keynote. One issue with biological naturalism is similar to biological naturalism with respect to flight, where there are a number of people, most of them engineers and general philosophers, who thought that humans would never be able to build flying machines. So that some kind of biological naturalism says only biological organisms have these magical properties. But you would think that they would refer to biology to make that claim, right? Are there some kind of ornithologist who actually has some kind of evidence that birds do something that machines cannot do? Of course not. But there is nothing in biology that ever made people think that because of what we know from biology, birds cannot fly. It was the outsiders who thought that. And I suspect that there's a similar thing going on, because none of the theories that currently exist in neuroscience and physics strongly suggest that there is evidence that computers cannot be conscious, right? Because none of the mechanisms that we know cannot in principle be emulated on computers. This does not mean that such results would not come in the future. But at the moment, the idea of biological naturalism is not the result of people studying biology and saying, I'm seeing something here which cannot be done on a computer. The notable exception might be Stuart Hameroff, who thinks that he sees something that is very difficult to implement in computers. But he is not in the mainstream of the field, and most people do not take him that seriously, which might be unfair, but biological naturalism at the moment, I think, is mostly a spiritual position. It's one which says, or it's one that goes from, I cannot see how computers are doing it, yet biological systems are somehow doing it. Maybe there is something that the biological systems can be doing. That block is a precursor to the Chinese room. He came up with this even more interesting and mind-blowing idea of the Chinese brain. He says that imagine that you build a computer where every neuron is basically a Chinese person, and they are now exchanging messages to each other to perform cognitive tasks. And when you look at this arrangement, you will not say that any of them is sharing in the consciousness of that shared thing, or that the shared thing is somehow producing consciousness. So neither input-output production nor the internal processing can account for the nature of experience. Fred Retzky is more optimistic. He says that phenomenology can be explained as a representation of contents, which is called representationalism. And Michael Tai makes this a bit more concrete and says we need to have something like first-order representationalism. Consciousness is an intentional state that is directed on representational contents. And David Rosenthal says it's actually we need higher order representations, higher order thoughts. So we go from first order representation, FOR, to HOT, to POT. And of course, some people point out, like William Lycan and David Armstrong, that this is not actually accurate. We need higher order perception. It's a difference between thought and perception. And FOR is inferior to HOP. So we need HOP instead of HOT. Ned Block, again, at a different stage in his life, is pointing out that there is access consciousness, which is leading you to perform actions and say things and self-report. But there might also be a different form of consciousness, which cannot be explained as access consciousness, which is phenomenal consciousness, which is experiential. So there, in this view, there is something that can be experienced that doesn't have causal power, and vice versa. There can be consciousness that leads to, because the system knows that it sees something, to actions, but is not actually experienced. And so he's pointing out that phenomenology and behavior are separate categories and might not have to be related. Colin McGinn has given up. He basically points out that maybe this all has a decent explanation, the way in which consciousness works, and it's a completely innocent thing that is implemented in some functionalist way or not. But no matter, we cannot understand it, because our minds only have two kinds of mechanisms: this perceptual mechanism by which we are making sense of reality, and the reasoning mechanism by which we can reflect on our perception. And neither of them is suitable to actually make sense of consciousness. So our brains might be ill constructed to actually understand consciousness. And this position is called Mysterianism. Of course, there are people which are much more optimistic and go in the other direction, just construct solution. For instance, Bernie Bars, this is his global workspace theory, which says that consciousness is basically an attentional spotlight mechanism in working memory. And the contents in working memory are constructed by all sorts of mental modules that are working together and are putting the information there. And the attentional spotlight has this purpose of redistributing and broadcasting it again to the different modules. There are also integrated information theory, which tries to be an alternative to functionalism, by Tononi, which basically says that consciousness results from integrating information, which doesn't sound to be wrong. But an issue with the theory is that it is, on the one hand, not denying the Churchill thesis, but makes very strong claims about what integration of information means. In some sense, it means mutual information within the mind. So when you are separating the mind using a knife, and you look at how the different parts are correlated while they're evolving, this is the measure of integration that you get. And his intuition is basically that this is not given by the way in which the information flows through the function, but by how it flows through space. That leads him to say that, for instance, a neuromorphic computer that is somewhat brain-like, even if it's digital, could be conscious. But for Neumann computer, someone like this that operates in information sequentially cannot, because it's basically only doing some kind of feed-forward computation. The problem with this argument is that you can emulate the neuromorphic computer on this computer. It's just going to be a bit slower, but that's not the issue, right? It's going to be computing the same function, so it's going to make the same output. It's going to move its mouse in the same way. And now you have this very weird situation that your neuromorphic computer says conscious things because it's conscious, but your phenomenon computer says the same thing without being conscious, which means it's lying now. But since lying is a functional object, right, it means that both are lying in the same way. And so now you're an epiphenomenalist, which means the consciousness is not causing the neuromorphic computer to say something. If you fix this, in my view, you get IIT to be a version of global workspace theory. So the fact that IIT is so popular is undescribable to me and unexplainable, except that it's somewhat controllable. How well does the theory work among philosophers if it's formally incorrect? So the perspective that I'm normally taking and that we are taking at CIMC and probably in the context of an AGI conference is computationalist functionalism. We can describe consciousness formally as a causal process in a constructive language. And functionalism means that consciousness is defined by what it does, which means operating on mental states. This also means that in principle, if the substrates are fast enough, should be able to run on different substrates, if they can run the algorithms necessary for this on different substrates. So what we mean is by consciousness, of course, our second order perception, the perception of perceiving, and this experience of a now, and the experience of realness, which are certain perceptual features according to this idea. And functionally, it's an operator on mental states, which means it changes mental states when it comes along in a characteristic way. And I think the way in which it does it, it creates coherence, which means it minimizes constraints violations in a dynamic model, and it facilitates spreading of organization, and thereby acts like the conductor of the mental orchestra. So its purpose might be increasing coherence in our mental representations, which is a kind of machine learning algorithm for biological systems. It stabilizes the observer, so it has a starting point for maintaining the self-organization of the mental contents. It resolves incoherence to directing attention and construction. It serves attentional learning and reasoning. It's the origin of mental complexity, rather than its result. It's called this the genesis theory, that consciousness is basically constructing our mind rather than the other way around. Something that is very early on discovered. And this is a hypothesis about how the mind works and how consciousness works. It doesn't have to be true. It's something that is to be tested. It's an interesting question whether consciousness is binary or not. Is it more like worms, it's continuous, or is it something that is like fire, which is on or off, it's ignited or not? And I am part of the minority that thinks that consciousness is much more like fire or pregnancy. That is because it modifies the substrate in such a way that once it's ignited, it stays on for as long as it can until the substrate is basically exhausted. It means it's autocatalytic. That's a big difference to the LLMs currently that are not autocatalytic. Basically, the presence of the transformer does not make the emergence of more transformer-like stuff likely. So we can ask ourselves if LLMs can be conscious. They certainly don't have to. Right? When you produce a text return, you have to be conscious. The LLM does not. But when the LLM is asked to produce an interaction partner that self-reflects and so on, it can make a credible simulation. And the question is the simulation more simulated than our simulation of what it's like to be? And that is a very hairy question to which philosophers at the moment do not have really good answers. The self-reported LLMs does not really help because LLMs are trained on deep fakes of conscious experience, many novels and so on. And so the question is much more not does it talk about its own consciousness, but is it acting on a causal model of its own awareness? And does the system possess an integrated model of now? And that would require some sort of mechanistic interpretability where most people don't really know what to look for. But it's something that the AI companies starting to go into. And so from our perspective, the machine consciousness hypothesis that we are studying is twofold. It's the functional nervous system hypothesis. The consciousness is the simplest causal pattern that the brain can form to facilitate attentional learning, rate modeling, agentic control, and that it automatically leads to the experience of what it's like. And that it's being found by nature by some search process over evolutionary and individual time spans. And if that is all true, then the machine consciousness extension comes into being, which means we should be able to recreate these conditions for self-organization in computers. Now, the theory can be wrong in many ways. We don't really know how it's implemented. We don't know if computational functionalism is correct. We don't know if our metaphysics is right. But we should expect that it's right. It should be our null hypothesis. One thing that I find really fascinating is regardless of whether you ascribe consciousness to the present AI systems, it seems to be that they give tentative evidence for the possibility of consciousness, simply because they produce a range of phenomena that would lead us to believe that consciousness exists in humans. And philosophers are often surprisingly reluctant to update. So there are very few people who say, I believed in the Chinese room so far. OpenAI has built the Chinese room a few years ago. And my ideas have changed now. This doesn't happen. Instead, philosophers mostly stay with their brands, which means we are still forced to do our own thing. And maybe philosophy updates like other sciences and other fields one funeral at a time. So it's the new generation, us, who have to work on this. And I'm glad to open the workshop with this.
Maybe 5 minutes for questions.
Thank you. What does a self model add to consciousness on your view?
You can be conscious without a self, right? Which means you can be in a state, for instance, in a dream at night, that stuff is happening, and there is clearly an experience of experience, but there is no observer present that notice that it's the observer. But to know that you're an observer, it's insufficient to observe. You also need to notice that there is an observer, some kind of unified entity that is making these observations and can be delineated against things that are not observing. And so the observer is a particular kind of content. And conversely, you can construct such a model of an observer without this being experienced. And so consciousness and self are orthogonal notions.
On that note, what about lucid dreaming?
Lucid dreams are dreams in which you typically are partially dissociated. You cannot access your sensory perception of the outside world. So you're not predicting reality, you are in your own insulation, but you are not as dissociated in normal dreams. So you are developing a sense of agency and you have access to some of your memories. Typically not long-term memories. So in lucid dreams, I have difficulty to remember my name, which city I'm in, but this might differ. Some people have more access to this. And it's trainable. So what I suspect happens during a lucid dream, that at night, when your mind is in a state of dissociation, it lacks access to some of its modules. And so you have started to string some of the modules together, but not enough to wake up, to get in contact with the outside world, and to make sense of it in a coherent way. Instead, you are dropped into your own mental cyberspace and can play in it. And you can induce lucid dreaming somewhat reliably by training reality checks, which means you make it habitual during everyday life to try to remember whether you're dreaming or not. And you can test this. For instance, if you read your watch twice in dreams, this doesn't work. Or if you read a page on paper twice, this doesn't work, which is surprising that your working memory has so few coordinate bits. You can also try to jump off the floor and see if you can fly. If it works, you're not in reality. Right? And so if you take these reality tests and train them a lot, then chances are that you do the same thing habitually in a dream, which can help you to bootstrap this process of becoming aware and pulling yourself together. Does this help?
One more question.
I'm curious your interpretation of the J-space paper by Anthropic, which seems to imply that there's this activation space that represents some concept that the LLM used then to answer questions, first the internal space. Have you read that paper?
Yes, but it's a very difficult thing, and I guess it would deserve a workshop on its own right to say what actually counts as evidence that you are finding consciousness. So you will expect that there is some kind of structure that you can find, but similar to the default mode network in neuroscience, there is the question to me, what would the opposite of this finding look like? So for instance, if you put a lot of people in the scanner and you don't give them a particular task, you're still going to see something in common, right? Is this the general state of anxiety when people are in the scanner, or is it some background activity of the brain or not? It's not clear, but you can give it a name in the default mode network, and then it's established and people are going to publish about it. But what would it like if the default mode network wouldn't exist? Would you see something different in the scanner? And this is the question that we would have to ask for the J-space network. So is this something that is very, very specific to this? And is it actually explaining the phenomenon that you want? But it's a tricky question, and I hesitate to do it justice by trying to answer it in 10 seconds.
Okay, thank you very much. We're moving to our next presenter.
Okay, oh, sorry. Really quick housekeeping. As you can all see, this room is open, and so if you're having a casual chat, try and give us like a 10-meter burst. Otherwise, I personally will hear you. We are going to get a microphone set up in a minute. Also, other quick housekeeping on the schedule, because we started a bit late, we're going to move Anna McCade's talk, which is one of the co-organizers, into the first thing in the afternoon. So you should all be able to get out around that point. Cool.
Yes, I think so. There's so I guess the same.
Anna, she's distributed.
How do that?
Yes, I have to look a lot of these down.
Yeah,
also be visible on Zoom. Okay. Okay. So. Hello, everybody. My name is Franz. Let's wait the two gentlemen in the second row to finish their talk. My name is Franz, and I will give a slightly shorter presentation now than Joscha's presentation on what I would call the phenomenal target, the explanatory target phenomenon of phenomenal experience. Because in lineups about consciousness research, usually people present a lot of theories, and it's often not so clear what they actually mean by the term consciousness. And it's also often discussed that this term is insufficiently defined as of now, and so on. But my claim is that actually most people, or almost all people that are interested in those things, are puzzled by a similar phenomenon, namely this phenomenal aspect of it all. Even though you might have a bunch of theories that use different formal frameworks and that sometimes incorporate the self or the self model, and sometimes they don't, mostly this aspect that puzzles people or puzzles us is very specific. And even though it's not yet clearly defined, it's happening in all of our phenomenal embedding spaces right now. There seems to be something happening to us right now that's somehow not adequately addressed in any kind of theory. And somehow this seems also to be something that maybe in principle cannot be adequately addressed. But before I begin this, and this relates to what Joscha talked about with epistemology and metaphysics. Epistemology and metaphysics sounds sometimes a bit like archaic, like ancient, or not ancient, but philosophy from a few hundred years ago. And today we don't need that anymore. We have science and we have institutions and so on. My claim would be that it's still super important to do this properly. It's not that you can read Kant's Critique of Pure Reason and read this as a nice historical document on maybe how the mind works. It's still very relevant. And many people don't do that anymore. They just start with some discipline, and this discipline is populated with theoretical entities that they assume, and they become very proficient in applying those theoretical entities to each other and talk to other people. But in the end, they do not really go down like, hey, where do I actually start? Where do these entities that populate my theories come from? Are they justified or are they not justified? And then sometimes you have this moment that when you tell someone, oh, I'm interested in consciousness or phenomenal consciousness, then they ask you a bit like, is it like bits or atoms? Is this like information and computation, or like physics and the real universe and so on? And also being the oh wait, I thought it already showed another slide.
Yeah, maybe we need to resubmit it.
What does resubmit mean in this context?
There's such a
Okay, give me a second. I mean, you can touch whatever you want here. Just I barely ever use Zoom, so I can stop. All right, let's try again. This one, right? Can I switch to the light now? Like, yes. So? No, it doesn't do anything.
You maybe keep it small, because then if it's moving on the full screen, maybe then they can switch. Yeah.
Oh.
But just manually.
All right. Okay, I'm back. Are you still here with your attention? There was a slight interruption. Okay, cool. So people then start asking me, hey, is it like about information with you, or are you about like physics or the real world? And if you are in the domain of computational functionalism, which is basically the framework under which we operate, it's sometimes very hard to communicate what we actually mean by it, because this term has been around philosophers, analytic philosophers of language have used it in certain ways. Other people use it in other ways. And Youssef, as you later will see, will probably also address it, but in a way which I would claim is straight wrong. So it's a term that has a lot of weight. And I personally like the term epistemological computationalism a bit better. But just regarding computational functionalism, I think when physics and computation are compared in these debates regarding consciousness, I don't think these are really things that you can compare on the same level. In some sense, you could describe physics. I mean, Joscha also gave his rough definition with translating everything into a specific formal system. But you could describe physics as the attempt or the collection of all formal theories and frameworks and models and structures that are used and being put together in order to predict and correlate all observations that have ever been made. And in the best sense, of course, without a contradiction, that everything fits together. So you could call physics the attempt at the critique of pure observation, so to speak. And computation is a slightly different thing. You could say it's the result of the critique of pure language. It's basically the search for the set of all possible formal languages and frameworks and models and structures that work out that are implementable. So it's the result of the search for the ultimate tool, so to speak, for the ultimate abstract tool. And now, once you've found that, and once you maybe formalized it in a truly universal manner, then it means that whatever tools you want to use for physics, of course, they have to survive the critique of the ultimate tool, so to speak. So computation is more about the set of all possible frameworks and languages that can be used, and physics applies those to observations. So they happen on different levels. So when you're in these debates and you're getting asked, are you like computationalist or more like physics and real world, it's really, I think, the wrong level of comparison. And I think those questions are really important for consciousness research, because otherwise you will not get along. And with get along, once again, I don't mean to align an opinion, but you won't even understand what the misunderstanding between you and someone else is. And that happens a lot in consciousness research. So once again, it's very important to figure out what are the entities and the axioms that populate your thinking, and where did you get them from, right? When someone comes out and says, look, computational functionalism is insufficient to describe consciousness because consciousness is generated by biological systems that arise in kind of real physics or whatever, then I want to know, what entity is this real physics? What parts of it go beyond computation? If they go beyond computation, where did you get them from? Did you observe them? How did you ever have an observation that consisted of more than a discrete and finite set of bits? Like, what magical observations do you have? And so on. And many people just start off like, hey, no, this is insufficient. And it's very intuitive, but of course, your metaphysics have to survive beyond what is intuitive. And so I would like to revive a little bit this like metaphysical debating and epistemological debating in a very strict sense. It's very, very important. Okay. So let's get back to the notion of phenomenal experience. Even though it's not properly defined, I would say the core extension, and with extension I mean a way of defining something, just what belongs into this notion that we want to try to define. The core extension of the concept of phenomenal consciousness, I would claim, is known to everyone who is interested enough to come to such a workshop, even though it's not clearly defined. And I would say the core extension is a certain very basic aspect of our phenomenology that puzzles us and that has not been adequately addressed. Normally, when people do consciousness research, they do not start this by trying to figure out, oh my God, how can vision ever be possible in an artificial system or whatever? There seems to be a specific subset that's very hard to point to, but somehow it's happening all the time that they want to explain. And so one could say the definition of the target phenomenon is not yet formalized, but indexically disambiguated and kind of point towards what we mean. And I would say the disambiguation goes so far, there exists a phenomenon, which phenomena just means some kind of appearance in your experiential space right now as well. It's happening right now as well to you. So there exists a phenomenon or class of phenomena, namely these direct, pre-reflexive, perceptual structures that seem to stand in need of an explanation. And so the question regarding phenomenal consciousness would be, what is this unknown representation achievement that all of our minds make happen right now, and that we do not yet know how to replicate in other kinds of systems, and that we do not yet know how we would test for that in other kinds of systems, even though it's happening all the time. What is this weird self-revealing shape that inhabits all of our embedding spaces right now, all the time, basically? And what distinguishes this kind of representation from other kinds of representation? When we ask this question, of course, it has to be explained, so it means it can't be assumed. That's also a thing that sometimes happens in consciousness research debates, that you are in a lot of discussions, and then it's about, well, shouldn't consciousness be fundamental versus not fundamental? But this is also a type of discussion that is completely detached from the attempt of explaining something. Right? If someone tries to discuss with you, hey, it has to be assumed it's fundamental because it's the starting point of every kind of thought or every kind of perception or any kind of theory, and I'm like, okay, that just means if you want it to be fundamental, then you use it as an axiom, but you're not explaining it anymore, right? So it's not a debate regarding a possible explanation of consciousness. If your position is it's fundamental, and you mean by this, well, you start from it, you need to assume it because it's there, right? Okay, fine. But you still didn't tell me or yourself, for that matter, what it is or how it works. Okay, so then you're not interested in consciousness, that's fine, but why do you go to this conference? And of course, the interesting step for an explanation is how can you get this phenomenal consciousness from no phenomenal consciousness? Not how can you get it if you assume it to be some fundamental quantity of the universe, and if you put it together in the right way, then you get it. I still want to know how do you get the small piece of phenomenal consciousness that you then put together in a specific way, right? You don't assume it, it's not part of the axiomatic framework, and you show how you can bit by bit gaplessly construct it. That's an explanation, actually. So the interesting thing is how can you get from like no lights on to lights on at some point? Also, what is meant by understanding? I mean, it's also this, but sometimes I think intuitively, when we understand things, it's also that you are sometimes able to understand something by fully having the semantic shape of a thought in your working memory, in your own language of thought, which is very different with different people. And my main example is sometimes that when you like have a first order logic proof in philosophy, you learn all these techniques, how you can go from line to line and you solve it in a calculus way. But sometimes it's also that you go through it and you see all the relations, and for a brief moment you have actually the semantic shape of what is captured by the notation on the page, and you understand it, you like see it for one brief moment in the language of thought, and then it's gone again. So that might be also an interesting aspect of understanding that I would want for myself and for everyone here to have regarding their own phenomenal experience at some point, that you can actually see this. How can you get it from not being there? Like for one brief moment, and not just that you see, okay, these are the roots and the axioms, and I understand their sound, their proof, and I go through it, and then at some point I get from no phenomenal experience to phenomenal experience. That's interesting, but I would also like this to be intuitively understandable in some sense. And with intuitively, I don't mean that it's not rigorous in the thinking, but that you are able to upload the shape of the proof into your own language of thought. And I think this seems so weird for phenomenal experience, and this is expressed in this notion of the heart problem by David Chalmers. Mostly that we somehow think even if we had a system that produces phenomenal consciousness nomologically, so by the laws of nature, we would still not understand why it follows logically, and we cannot really understand it. I think there are, of course, a lot of problems with that paper and so on. But I think this is what he tries to capture, and this is why it resonates so much. So phenomenal consciousness is there, of course, independent of what it actually is in the end, or what is ontological status with regards to what's real is. It's clearly happening right now, even if it's a complete illusion. Okay, and this illusion has a weird, puzzling shape. How does this kind of illusion work, right? So it's still interesting. It's obviously there. And I addressed this 2 slides ago. It is our epistemic starting point, of course. We all start out with phenomenal consciousness. But that does not mean that we have to presuppose it as a basic aspect of our world model. Epistemic starting point just means that whatever theory about a world or universe or whatever you construct, starting out from consciousness as a conscious mind, has to give you consciousness back at some point, right? Because otherwise, it's probably not a world in which you find yourself that you construct. But it's different to have an epistemic starting point versus to assume your epistemic starting point as an axiom, right? Just because consciousness is directly there doesn't mean it needs to be fundamental. It just means whatever fundamentally is the case or is implemented needs to work in some way that gives us conscious experience back at some point, that an observer can ask this question in this room. So that's very, like, people confuse this sometimes. Epistemic fundamental starting point is different from fundamental axiom of your worldview. Just because you start from something doesn't mean that your implicit metaphysics can have it at the lowest level. Yeah, must be accounted for is different from must be presupposed. So, phenomenology, the specific representational regime that takes the shape we call conscious experience, can we look at it separately from other mental phenomena that usually come alongside with it? I mean, Yosha already addressed some of these aspects. I will nevertheless go through some of them again. The most prominent endeavor, to my knowledge, is, by the way, that tries to isolate this notion of phenomenal experience from other mental phenomena, is the Minimal Phenomenal Experience project by Thomas Metzinger. There's a long book called The Elephant and the Blind. It's downloadable by MIT Press for free. It's a very poor book. It's a bit long and repetitive, so I wouldn't read it cover to cover. But it's very nice to check it out and try to get a sense, like, how can one approach this minimal model explanation of this aspect of experience that we're interested in? Yeah, you can take a screenshot of the slide because I won't go through it. In that sense. So the first part, I would say, Yosha already addressed this regarding the higher order thought theories. There are other problems with the higher order thought theory, by the way, not just that it's not thought, but also how the thought becomes conscious apparently. But phenomenal experience itself is not thinking about thinking. It's sometimes how people think about it when you talk about this, like, hey, somehow the modeling itself seems to be modeled and it's very interesting, this representational shape, but it's not that, okay, I'm thinking about the fact that I'm thinking. This plays out in consciousness. You can do this right now. It's an interesting mental state to be in, but consciousness being, as in phenomenal experience, was there before that, right? It's there before that, and you can then let it play out in it. It's also not thinking about yourself. It's not this ability to linguistically point to some entity that is yourself. That also plays out in consciousness. And the self can be absent in certain dream states or drug-induced states and so on. And that, Yosha mentioned it as well, but conscious experience, phenomenal experience, is also not about the self or the self-model. The self-model would be basically a multimodal or supramodal entity made up of visceral sensations, geometric perception, autobiographic memory, and so on. So a conglomerate of representation language that are stitched together to represent the current state of the system that is implementing this representation entity. That would be the currently active self model. And the self is an abstraction about a sequence of the self models, where basically there's a caricature, the statistical properties of sequences of self models are being summarized, and then you think about that as yourself, kind of the stable patterns of all these self models that are active. But also, there are many states where in Metzinger's lingo, an abstract hyperprior has been episodically suspended, and there's no currently active representation of a self going on, but experience is still implemented. So experience is representationally disentangled from a self or a self model, or from thinking about thinking, even though in our everyday life, these things almost always co-occur. That's why, of course, these like out of distribution mental states via drugs or mental sickness or whatever are so interesting with regards to trying to isolate states of consciousness. I should be done in 5 minutes, right? And also, and this is a bit of a weirder take for people, phenomenal experience is not about subjectivity. Subjectivity, as a certain kind of perspectiveness, doesn't need to be represented. It is also a representational property. You could have some system that represents experience without wrapping it into any kind of perspective, without representing any kind of epistemic agent model, and so on. So the conscious state, of course, would be implemented by some entity. So it would be subjective in the trivial sense that some entity implements it, but it doesn't mean that the representation of experience contains any kind of representation of subjectivity. And that's a bit weirder, because subjectivity is even more deeply ingrained in our everyday shape of experience than the self-model. Many people here probably had like moments where the self-model thought after waking up had to be booted in your experiences. So it's like, oh God, I'm this person and whatever. Subjectivity is a bit more tricky. And it is treated in relative depth in The Elephant and the Blind, if you find that weird. But it's a very important aspect, because otherwise you have all these weird subjectivity arguments in philosophy that just assume this, but don't really try to define like what actually is subjectivity, what you need for it. It's the fundamental aspect of any kind of representation. No. So, was ist der Seelengrund? And I like this phrasing, Meister Eckhart meant it in a different way, of course, but what is German for what is the ground of the soul? What is this basic representation that seems to be almost always there, and then everything else seems to be wrapped into it. So what kind of representation is phenomenality? Now, as I mentioned, a number of approaches are compatible with the general direction of what I'm saying and also what Joshua was saying. But first of all, I would say we can look at 4 representational constraints. And I think these are also important. Because if I'm just telling you, well, it's some kind of recursive iterative modeling, then you might say, well, okay, we can build that, but why does that feel like anything? I think this feeling of what it's like, this phenomenality, will arise from a recursive representation that fulfills very specific representational constraints. And I think the nuances are very important there. We actually want to get from recursive higher order modeling to this notion of a feels like something representation. First of all, it has to be, you could also say it has to be a representation of perceiving, but not of thought. We already went through that. It's just slightly repetitive now. Sorry for that. First of all, it has to be perceiving of perceiving and not thought. And then the important other aspect is that it's also sometimes misunderstood. When we say second order perception, when people hear this as something that is also containing on the representational level something about meta something. But they would say, well, our experience is clearly not second order. It's like directly given. It's like our first order thing is happening right now. And the claim here is that second order perception refers to your first order experience. So your first order experience is already a second order perception or representation of second order perception. That's very important because otherwise it's a bit weird. Okay, it's directly given to me. It's like my direct experience, and this is now a second order thing. So your direct experience, your first order experience, is what is meant by second order perception. Second representational constraint is the phenomenal transparency. So it is a representation that is not tagged as a representation. In your world model and in your experience, there seems to be a gradient. You can have abstract thoughts, counterfactuals in your head, and somehow they're tagged as not real. And some other aspects in your internal world model are tagged as real, or at least not tagged as not real, such as like this table in front of me or this computer. It's like I can think about it, I can realize how the visual cortex works, and I can deconstruct my reality, and I can kind of know that this is not direct reality. But that doesn't change. That doesn't change the shape of the representation. It's still represented as real, right? You would have to fully deconstruct it meditatively to actually change it on the level of representation that it's now also tagged as not real, or that the realness aspect goes away. And conscious experience is of that type. Conscious experience, phenomenal experience, does not contain information about the fact that it is a representation. And even if I'm theorizing right now, and even if I would be correct and I realize, oh my God, it is a representation, that would not change the exact shape of that representation. Because in order to be tagged as a representation on the same level of representation, this level would have to encode, oh my God, this is not real. Such as some of our thoughts or abstract other ideas do contain it. You don't have to think about it, it's just tagged as not real, whatever that means. This is the second constraint. And then the representation is probably statistically simplified in that sense. I mean, emergent, or what Hofstadter means with like the strange loop. I don't think that the strange loop is exactly what consciousness is and so on, but there seems to be some kind of iterative processing that abstracts the shape of the model into something that is simplified in a similar way, in which like liquidity is a simplification of the interactions of a myriad of individual like molecules, or call them transition functions or whatever. So you lose some information and you have a new function that captures the dynamics of something. So it seems to be statistically simplified representation. And then also a big part of the first constraint already, but perception of perception and perception have to happen on the same level of representation. So I mean that if you imagine some kind, let's say, some kind of embedding space or semantic space in which information is coming in and it's encoded in some way, then you would have this perception would be this direct registration of structured content coming in. And then this content coming in would already have to be shaped in a way that encodes that content is coming in. And that's this weird thing about experience. Experience, like what's happening right now in our experiential space, somehow already contains information about this happening right now on the layer on which it happens. So this meta modeling is happening on the same layer of representation and not on another layer. That's why it has this weird self-revealing glow to it. Like even without thinking about it, you're like, oh my God, the representing is represented right now, even if you don't think about it. Like, how does that work? And one more. We have questions in a minute, or is it very specific?
No, it's
okay. one general important sentence, we're not looking for some kind of pattern or shape or representation that then somehow feels like something. I mean, we're looking for the feels like something structure. Feels like something, or this phenomenal glow of experience is also in a specific way. It is a specific representation. So we're not trying to close a gap here where I show you, oh, this information structure for some reason feels like something. I'm trying to think about what representational structure feels like something, because obviously it is in a certain way. It happens to all of you. It's different from other things that don't puzzle you. So what is this exact shape? And then, yeah. Yeah, and just lastly, why these self-organizing paradigms? Well, to me, it's interesting if you assume like some kind of hypothetical universe, just assume there are no representations yet, no concepts and no ideas. And you just have a set of autonomously organizing systems that somehow need to control their own representational process, their own model-making process. So they would have to kind of bootstrap the shape of their model-making process within their own modeling space in order to regulate it. But they cannot refer to anything. There is no thing such thing as reference yet. There are no concepts, no ideas. It cannot be coded in from the outside. So these systems would have to kind of twist and shape their own embedding space in a way that contains the current shape of the construction of that embedding space in their own formal language, basically. And wouldn't that be a weirdly self-revealing archaic shape that these systems would be confronted with and that would be puzzled by? Like, oh my God, what is this? Why is it so weirdly self-revealing in nature? So that would be a little bit into the direction why evolutionary that happened at all. Because I think if you start from a world where the notion of epistemicity or representation or knowledge or modeling doesn't exist, and you just have these systems that need to somehow encode that on the lowest level semantics that they have access to, then of course they wouldn't be able to encode this in like a very specific, explicit pointer language with ideas and concepts. No, it would have to be in the shape of the representation itself already that the representation process is happening. I think that's very close to phenomenologically what actually happens here. Like, it's just contained in the bare shape of experience that perceiving is being perceived. All right, that's it now. We have one question that maybe we should answer first.
Yeah, of the 4 bullet points,
yes,
the perception of perception has to be on the same level.
Yeah.
It's not clear to me why it has to be. I mean, it can be subjectively perceived as if it was at the same level, but in the architecture inside.
I'm not talking about the architecture. So I'm only talking about the shape of the representation. That's why I mean representation constraints. So you have to imagine I'm doing kind of phenomenology, like some philosopher just looking at the shape of experience. What is this, and not how's it implemented? What are the physics or the architectures of the systems that build it? Right? It's about the structure of the representation.
But the representation is part of the system, right? That you want to build it, it has to be part of the system.
Yes, exactly. But I mean, this is about the shape of the representation, and how the system realizes that doesn't matter. So it's a bit like no matter how your experience right now is realized in your organism or whatever, I'm just talking about the shape of the experience. Like what is the structure of the experience, and not on what levels does the architecture of your brain or whatever you want to call it realize your experience. So it's really just about this layer of experience.
I mean, it's a very specific constraint. It's a very weird constraint to demand that the representation has to somehow represent itself within itself. That's usually not. I haven't encountered any representation that has this property, to be honest.
I mean, the hypothesis, of course, that your conscious experience right now is exactly that.
But why would
and it is also weird.
Why would you even demand that?
Because it seems to be the case that if you have this, if you phenomenologically perceive, and you also perceiving, it doesn't seem to be the case that you have to point or think about it. Just as it happens, it seems to be happening on the same level of your perception already. So basically, let's say the chair you're sitting on, you feel that right now. It's represented on a perceptual layer, directly given, so to speak. And consciousness, this perception of perception, seems to happen experientially on the same layer. It's not detached from it.
I mean, in my subjective
experience.
No, but important. Like,
in my subjective experience, when I perceive the way the chair feels like, and think about the way I perceive that it feels, or perceive that perception, it requires temporarily further another step, and it feels like a different kind of thought as well.
When you think about it, yes, but my claim is that even before you think about it, the chair is consciously perceived, right? Like if you're sitting on it right now, the way it feels, and then you can think about like how does it feel, and in the next step you can reflect upon it. But this experience was already there, right? You realize, oh my God, there is the experience of the chair happening, and then you can reflect upon the experience. But the experience of the chair happens on the same level of representation as the chair. And the chair is a perceptual object. And that's why I think for phenomenal experience, you need to have this happening on the same level of representation.
I have doubts that the perception of me sitting on the chair happens at all before I think that I'm sitting on the chair.
But why do you then think that you sit on the chair if you don't have a perception of sitting on the chair in the first place?
Well, I can't think and then perceive that I'm sitting on the chair. But before I do that, there may be just this first level thing
Okay. I can't really follow you, but we can talk afterwards as well. But my claim is, of course, that the experience is there before you think about it. And yeah,
the experience is there, but it appeared to me that you claimed that there is a second order perception of perception at the same time as the first order.
No, the experience, that's what I tried to.
Perception that should.
Stop it. It's funny, but we need to take this point. So my claim was that your experience is already the second order perception. And that's what I tried to address in the first point. That experience itself is already the second order perception, which is your first layer of experience. You remember that point.
Is it like some third person is looking at you and?
No. Okay. Want to take it so far, and we can also discuss then in person. But that's a rough take here. And if you're interested in the representation constraints, we can also take our time. But now, but yeah, it's very important. Otherwise, it doesn't work.
This is the persistent index program. So if someone has to dial in.
Yes, this is there who's already.
He's
already in Zoom.
Okay, he's already in Zoom, then he takes the over for presents, and then he takes over this. I can probably chat.
Right. No, but yeah, this is.
Okay. Can you hear me? Can you hear me?
Oh, yeah. Oh.
Can you hear me?
Yeah, I have one audio. Let me see if I can turn on my audio. But I have no way to. Yeah, my audio.
No, I went to plug the speaker into the speaker. Let me get started. I don't have things.
Of course. Thanks for waiting to share any question.
Can you hear me?
I don't know if they know or not. We cannot.
The experience. First order.
Need to do it.
Hi everyone. So sorry for a little delay. We're going to start in just a couple of minutes, but if you do want to go to the bathroom, you can do so now. And last present very, very short.
Thank you so much.
Yeah. Maybe, I don't know. Yeah, my seventh one. My seventh. Building an AI. Yeah.
Everyone didn't hear you. Go on break for a few moments. We're just getting set up with our audio.
Yeah, we're presenting I posted a couple of days. Yeah, well, the model that we can build. We can interact.
Now here I am the chief of like wow, amazing. You also like your enthusiasm, how you approve or disapprove or something. I thought that.
Oh yeah, I try to give without speaking. I try to give them feedback. Like I'm here with you.
Yeah. Can you hear me?
It's like I mean, I was the person who didn't notice otherwise. Like in a normal conversation, you don't need to gesture so much, but in the audience, how do you know the audience is awake? Where am I from? Taiwan.
Oh, I know. So you live in Taiwan?
I live in Taiwan, so I'm here for the summer to work on projects.
I don't know if it's Taiwanese. Oh, I have a top Taiwanese. How do you name it? Where are you? Your name?
Spain.
Yeah.
Yes. Go ahead. Thank you. From Spain. Yep.
I'm happy at this.
You guys would have maybe met.
I think so.
Yeah, usually go to Good.
I work there.
Yeah, so
Yeah.
there's only 1 year that
I
you don't.
feel how big. I will send you. I'll connect with
They have presented. They have presented most of my things.
Oh, yes.
I appreciate every year the conversation there.
I have an article about the I-13. I will send it to you. Are you on LinkedIn? Okay, they are.
That's actually.
Oh, come on. We could have made your
I could have, but I thought I don't want to. She's probably notes. I didn't know.
Hanno un problema tipo di audio, non so, stanno risolvendo. Che c'è l'organizzatrice, dice no, ma io lo conosco. Bravo, però non si sente. Sì, è tutto bello, tutto bello. Allora, I'm interested to find out. Phenomenology. 35 years. 35. This time we came in, we also have to go take another trip in Oaxaca. I have seen the work with Madrid, Yep. And in North yeah. We presented part of the paper like the architecture in Osaka in Japan. We did a work too because we had for other what you do. So I don't know what he's waiting on.
For me, I see more evidence. But we have been developing it like, I mean, that we know on the rate and we just implement a model that's going to compute. That's what we did. That's what we did. And that's exactly the issue. Yeah. And meanwhile, how can I write? My second book and 8 books are going to be 60. That's going to be an Wikipedia of getting back 1,100 people from the party. So now to bring them together using AI. First, being able to create AGI data. And get a study from yeah, and they get really a few videos. Thank you so much. But they did get back to this right now. It does count. We're living on Thursday. More way, more clear than that's why I make it.
Be 2 minutes.
Oh.
The first weekend when we can see that comes far away from I usually try to build for this population, it was impossible, I try to build them. That's great. The adding one. Maybe you can switch somebody that is presenting physically while you set up everything. I mean, yeah, you're saying that to speak here. Here's the next one. Put the next one. Your suggestions to have everything else presented. While you. That's a good idea. Thank you.
Yes.
Can we have?
Can we have the mic?
Yes, mic has.
Yes.
Okay, great. Good suggestion. Yes. So you have time to set it up.
Yeah, absolutely.
Half an hour. I will give you 5 minutes for.
Yeah, it's fine.
Yeah, much better. Much better.
Okay, thank you. Get started in just a moment.
Oh, no, they moved me to the border. I hope they invite me. I'm gonna go. Okay, thank you for that.
Should be in the room now. Let me know if they're not.
No, we're not doing that now.
Yes, I agree.
Okay, I have a 40-minute presentation. I'm going to try to compress to 20 minutes, so forgive if I speak double speed. I am going to talk about how we might be able to unify the concepts of intelligence and consciousness, and talk about some of the big problems I'm interested in solving. I've been involved in AI for about 27 years. My undergraduate was in AI in UCL in London 27 years ago. There were 2 people on my course. Things have changed a lot since then. And I continue an academic career in AI. I've also started multiple companies that I've sold, and I now get to invest in crazy ideas like solving machine consciousness. So Consium is a company that I started 2 years ago to try to solve machine consciousness. And today I'm going to talk about a paper I wrote earlier this year that controversially argues that we're focusing on the wrong problem, but we can discuss that later. So this is me, it's boring. So let's talk about the problem. So the problem is that maybe a lot like you, I get an email every day from somebody telling me that their AI is conscious. I won't go through these, but I think 67% of the population currently believe that LLMs are conscious. And the reality is we can't say whether they are or aren't, because philosophers are going to argue for the next 2,000 years about whether what consciousness is. And so that's one problem we need to face into. The second problem is a concept called mind crime, and I'm sure you're all familiar with this, which is if we inadvertently create machines that are conscious, could we create suffering at mass scale? And then finally, the other problem I'm interested in solving is, can we build machines that are aligned with some sort of value system? So let's talk about AI. So I guess I've been building AI solutions for a long time, and when I build AI solutions, I usually have these 3 components. If I build a solution, I give data to it, it makes a decision. Tomorrow I give the same data, it makes the same decision. What I have is automation, and automation is amazing because we can get computers to do things better than human beings. But does anybody know the definition of stupidity? Doing the same thing over again, expecting different answers. I would controversially argue that by definition, automation is stupid. I know that everybody that currently touches these big words calls themselves an AI company. It's fine, you get more clients, get more funding. There are unfortunately many definitions of AI. The most popular definition, I think, is the weakest definition, which is getting computers to do things that humans can do. For most people, AI started 3 years ago with ChatGPT. And what we've managed to do is get machines to do things that humans can do: corresponding natural language, recognize objects and images. And when we get machines to behave like humans, and because humans are the most intelligent thing we know in the universe, we assume that that's intelligence. And by the way, there are plenty of books out there that will convince you that humans are not that intelligent. This is a different conversation, where humans are bounded. We're very limited by our intelligence. There's a much better definition of AI that comes from a definition from the 1980s. I love this definition. I've been talking about it for a long time. It's by Steinberg and Solder, which is goal-directed adaptive behavior. What you want to do is build systems that make decisions, learn whether those decisions are good or bad, adapt themselves so next time they make better decisions. And if I was being honest and controversial, if I held what we do in industry to this definition, then nobody's doing AI. Most systems in production, they don't adapt themselves in production. It's a ridiculous comment because, of course, we're all doing AI. But for me, the true paradigm of AI are systems that can safely adapt themselves in production. Anyway, so I won't give you a history lesson. You know all this. But my PhD 22 years ago was trying to model the brain of a bumblebee in a machine. Bumblebees have 1 million brain cells. Their brains can fit on the end of a needle. Bumblebees, just like human beings, do amazing things. They navigate 3D worlds, they talk to each other, they recognize objects, they solve problems. They don't handle windows very well, but ultimately they're very smart creatures. And the question was 20 years ago, can you build a machine that has 1 million neurons? We couldn't. We can now build machines that have billions of neurons. And of course, we call these large language models. And I think you know this, large language models are a very crude representation of our brain. Your brain does not need a nuclear power station to run. Your brain operates on the power of a light bulb. You don't need to be, I only have to say to you that this is a microphone once and you know what microphones are. You don't need to see thousands of examples of microphones to know what a microphone is. By the way, LLMs don't adapt themselves in production either. So you know, there are many innovations that are coming out of academia that are going to allow us to build much more adaptive neural networks. That said, these things are getting smarter, right? So 10 years ago, they were living like toddlers. They regurgitated some words. Most of it didn't make sense. ChatGPT was launched, what, 4 years ago now? And arguably ChatGPT is like an intoxicated graduate. 50% of what ChatGPT comes out with is confidently incorrect. We know that it's now graduated to like a master's level. We're starting to see some evidence of PhD level, so it can do science. I think, you know, the next few years we'll probably have a postdoc level, so that it can apply complex scientific method to solving very complex problems. And then, you know, by the end of this decade, we might all have a professor in our pocket. Now, this is probably one definition of AGI, something that's an expert at everything. I'm not here to talk about definitions of AGI. So how does it relate to consciousness? Often these things are separated, intelligence and consciousness. But if you ask people, and I ask people this all the time, what is consciousness? Most people will use words that I'll talk about later on. But there are plenty of books out there that will tell you what consciousness is. Many of these books are written by friends of mine, advisors to CIMC. You're going to hear from Anil very soon. I actually sponsor Mark Som's research and others. I actually struggle with all of these big words that people say. If I'm honest, I have a very simple view of the world. So I actually think that this is going to sound really arrogant. I've got my head around consciousness, and let me try to argue. So when you ask people what is consciousness, what's intelligence, they refer to features like language, long-term planning, metacognition, feeling, I don't know, these different things that we've talked about today. And I argue that these things have evolved over millions of years to allow us to either make predictions about the world or learn whether those predictions are good or bad. So they map to this definition of intelligence. And if you imagine each one of these features that we've evolved is like a segment on a color wheel. If you spin the color wheel, then if you have all of the colors, then what emerges is white. And maybe I'm in the Daniel Dennett camp here, which is, I feel like consciousness is an emergent property of the interaction of all of these different systems that we've evolved to be intelligent. That's how I think of consciousness. And when you stop the color wheel and you try and find it, it disappears. Which is why I think we're never going to find consciousness. So anyway, that's it. So what I've done is I've written essentially a book chapter. This book's going to be published in the next few months. What we've done is we've got 30 of the world's leading thinkers of consciousness. Did you contribute to chapter this book? I can't remember if we asked you. But we've got 30 of the world's leading thinkers that have provided chapters of this book. And if I get all of your email addresses, I'll send you a version of this book. My chapter is sort of arguing that consciousness is this emergent property from the interaction of these different things that we've evolved to be intelligent. And it draws upon leading things like Friston and Soms and people you're going to hear about today. And in fact, I won't go into the details here because I don't have time. But these, I think, are the features that allow us to be adaptive. These are the features that we've got from being able to predict, to language, all that kind of stuff. And my kind of argument is that if we put these features in motion, then this conscious experience emerges. That's how I think about it. So I'll share the paper with you, and that's all fine. But I think now this is the wrong question, and I think that people are going to be arguing about definitions of consciousness for the next 2,000 years. What I'm interested in is, what does it mean for something to suffer? I think that's actually the question that we need to solve for over the next 5 years. What's the minimum set of segments on that color wheel, and in what motion do you need to put that system in for it to experience suffering? And so I've had to stab at this. It's written in the paper. So this is drawn from that color wheel idea. It's also drawn from the research of people like Jonathan Birch, animal consciousness, and the sort of argument is that these 5 features here, when you bring them together and put them in motion, then potentially suffering can emerge. And I did have a question for you actually, Joshua, which is, you mentioned that consciousness was a fire, but that sentience was like warmth. But my feeling is that sentience, if you're sentient, you're conscious, but we can, I don't know, yeah, so that was something I need to kind of iron out. Anyway, what we've done is we've taken this concept called the minimal suffering hypothesis, and we've tried to then apply it to different kind of potential AIs, from LLMs to neuromorphic robots that have bodies, to organoids, to all of these other things. And so we have developed this methodology to essentially determine the risk of something suffering, which again I think is the problem we need to solve for if we want to mitigate mind crime. Again, I'm happy to share the paper with you. So let's talk about alignment. So this is actually my master's problem, not my master's project 23 years ago. So it was back in 2003. What I did is I created essentially a fish tank, a petri dish. And inside that fish tank, I created the primordial ingredients for emergent behavior. So things like the ability to bite, the ability to move, the ability to sense the world. And you created like all of these thousands of agents that were all stupid. Their genome was just random. So it created this random creature that just died because it didn't know what it was doing. But it just so happened that every now and again you created an agent that was able to see something, bite it, and then pass their genes on to the next generation. And what was interesting about this, and this is called artificial life, is that some simulations created speciation, predator-prey behavior. And what was also interesting is that I could create a system, a game, an environment where they had to lie, cheat, kill each other to survive. Or I could create a system, an environment where they had to be altruistic, sacrificial, cooperative to survive. By working together, they needed to unlock resources to pass their genes on to the next generation. And this is actually how I think about approaching alignment. I don't think it's possible to align LLMs. We have to have that debate. But through this evolutionary process, starting with very simple agents that are like insect level agents, and then using this sort of environment or environmental pressures, you can embed morality into these AIs. Absent of guardrails, will these AIs actually behave altruistically? Now, I actually revisited this recently. I've got Claude now doing this at scale, and so I now have being able to model essentially virtual stem cells. And these stem cells are behaving, as you would imagine, like the small multicellular or single-cellular systems. They're evolving the ability to have chemotaxis, so they're actually following food gradients. I now have multi-agent systems multicellular systems on the tens of thousands of cells. Those cells are turning into brain cells, neurons. They're turning into bone cells, muscle cells. And the question I want to pose everybody, by the way, you're starting to get this weird emergent behavior like predator-prey behaviors, etc. The question I want to ask you all is this, which is, if I took one of these multicellular systems and I looked at its behavior and draw parallels between the behavior of this multicellular system and a real world multicellular system. If I looked at its behavior in, let's say, strenuous circumstances, it will behave in a certain way. If I looked at its brain activity, it will have a certain brain activity. Now, if its behavior, external behavior, and its internal brain activity was similar to that of a real multicellular system, is this experiencing the same thing as a real multicellular system? Are these things feeling suffering, pain? That's a question I want to ask you all. And could you imagine to take this to now a multicellular system of tens of thousands of cells or hundreds of thousands of cells? Could they feel pain, suffering, anxiety in the same way that a bumblebee does? So I think that this is an important question to try to answer. So conscium is Latin for consciousness. It was born out of my desire to try to solve machine consciousness, and like I don't know if I'm bastardizing or sure what your thoughts are on this, but I think we're building towards a zombie superintelligence, something that doesn't understand pain, suffering, love, empathy. And the question for me is, can we build a machine that does understand pain, suffering, love, empathy, and will that be a safer superintelligence than a zombie superintelligence? So that's the question that we're trying to solve for. We've managed to attract some of the world's leading thinkers. This is just a small section of people, from Mark Solms to Anil Seth. They're helping us get our head around consciousness and getting our head around what it means to suffer. We also think that neuromorphics is an exciting substrate to explore these ideas. And if you're not familiar with neuromorphics, they're more sort of aligned with how our brains work. Your brains don't propagate numbers like LLMs, they propagate spikes. And we've managed to attract probably the world's leading expert in neuromorphics, Jason Ashranga, and his team to explore some of these ideas. And the other interesting question is, if you build something like those little agents I've created, or even LLM, can you verify if it's suffering or conscious? And so we've actually developed a technology spawned out of this moonshot. When you shoot for the moon, you invent things like Velcro, right? And well, the one actually that's not true. It's not. But anyway, it's a nice story. The one Velcro that we've created is essentially agent verification. So we can now take any agent, whether it be an LLM-based agent, a neuromorphic agent, even a human being, and we can test it for knowledge. We can test it for whether it has the skills to be able to do its job. We can test it for its expertise, plasticity. So how does it change and adapt in production? And we are now testing for consciousness. And we fund Cameron Berg. I don't know if you know Cameron Berg is now kind of a shining light in this area. So Cameron is helping us develop tests around consciousness, sentience, suffering for us to test for. And if you want to see it, you can go there. And beyond Contium, I'm interested in a bigger picture, which is can we make sure that governments are thinking about this. So I created a not-for-profit called PRISM, which is a partnership for research into sentient machines. We fund we fund researchers exploring these ideas. So if you're interested, go to this website. There's funding available. They create things like this, pretty diagrams to show you the landscapes of consciousness. And we create also things like these open letters to try to get people to sign up to building systems that potentially don't suffer. And we've had people like Stephen Fry and other famous people sign up to these letters. I think I'm going to stop because I know that you're having a lot of time. Sorry? That's okay, we'll answer questions. But so what I'm going to be focused on for the rest of my life is what's the minimum size system do you need to put together for something to suffer? And the other question I'm interested in, can we build an aligned, innately aligned conscious superintelligence that helps humanity navigate these questions? Thank you. Oh, you've got a few.
What about just a very simple top-level goal to be maximally useful to authorized users of your system?
The verification system.
Yeah.
Yeah.
Like as a way of forcing alignment, but for all sub goals that have to be, in service to that top-level goal.
Sorry, say that one more time.
All the involved sub goals have to be in service to the top-level goal.
Of these little agents I've created.
Yeah.
So the goal is not, I don't create a goal, right? So all I do is I create a primordial soup, the energy gradients and things like that. I throw up some stem cells in there, and the ones that somehow manage to follow the energy gradients and then have part of their genetic code to suggest that they replicate once they reach a certain amount of energy, their genes get passed on to the next generation. It's likely their children will have those traits, and then eventually get multicellular systems. So I don't give it a goal. This is an innate goal that they've created from surviving this environment. Yeah.
Yeah, these are received from. You mentioned Cameron Berg.
Yes.
We are screening his documentary called AMI tonight.
Great.
Are you going to be attending?
Yeah. I'm not going to be there, unfortunately, but Cameron Berg has created a documentary called Am I, which I'm a big fan of, and I'd recommend that you go and watch it. Yeah. 6:30 tonight. There you go. Nice little plug. Did you have a question back there? Sorry, yeah. Sorry, there's a light that got behind. So they do develop a brain structure. So these little creatures that I've created, this is again, I've not predefined this brain structure. They create neurons that are attached to other cells, and they've interpreted this as being like a light sensor, something to create thrust. So this is a brain that has emerged from that environment. And so the question again that I'm asking myself is that if the brain activities here are similar to the brain activities of real multicellular systems, are they experiencing the same world? It raises a question about whether we're living in a simulation as well, but that's a different conversation. Did you have it? That's a good question. I don't know. So yeah.
Or does if a bee suffers, there's a colony?
Yeah, so the question is, does a bee suffer? If a bee suffers, does a colony suffer? And I think that these are the questions that we need to ask. So that's why, if I'm honest, I think we need to stop arguing about consciousness and we need to figure out what it means to be to suffer. That's the big problem. Yep. Thank you. Say that one more time, please.
Generate models of others, mirror neurons are in
What do I think the role of mirror neurons?
Just generative models of others.
Generative models of others. Just help me to unpack that.
You think there's necessity to model others for a system to experience others?
So for me as an agent to know that other things are agents.
Well, not necessarily explicitly, not necessarily in language, but to have some kind of representation of others.
I think the answer is no. Although I think that it's one of the categories is a self model in one of the in one of the list of features. But I don't think so. No. But I guess this is for me a starting point to have the conversation. Yeah.
One question, which was, there is a lot of work for humans to like meditate down to jhana state 1 and have ego dissolution and other things, and those are really trying to get rid of the suffering experience.
Yeah.
So, I'm just kind of curious, how do you compare that against this point of suffering being central?
This is a bigger question, isn't it? So I'm not saying that suffering is central to consciousness. Sorry. Do you want to just stand up and say I'll try and repeat.
Sure. The question was that a lot of humans do meditation to try to get to jhana level 1, I think, and as well as like ego dissolution and other things. And so I was just asking how fundamental is suffering to consciousness if, we have this like ideal human who gets.
Okay. So I think there's two things here. One is this idea of, okay, I'm going to go off on a tangent here, but I assume that some of you have like a voice in your head, like a chattering voice. Some of you might, so actually I have no voice in my head. I have a thing called anandaphasia. All I do is experience the world through feeling. So I don't have like a thing chattering away. And so but I still suffer. and so I think there's a pursuit of trying to remove your chattering negative voice or whatever goes in your heads. I think that's one thing that people are interested in, but I don't have a voice, but I still suffer. And I think we still need suffering to understand whether to get feedback about the world. Is a decision I made there good or bad? Feeling pain, and there are different levels of suffering, of course, and I've tried to highlight them here. So actually, some people like pain, right? And but some people feel lonely, and the question is, can a large language model feel lonely or anxious without necessarily having pain receptors? And I think this is really the question that we need to unpick. The reason why I'm focusing on suffering instead of other types of emotions is because I think that's the problem we need to solve to mitigate mind environment. So suffering is just one the whole array of things, but I think that's the problem that we need to mitigate. Yeah.
Good question. There's a large body of work for affective computing.
Yeah.
It seems like a little bit of extension on that, which has all kinds of feelings that can be sensed by the system, right? And then we're talking about suffering, which is at a high level of that. Yeah. So have you looked into that?
No, I haven't. I guess I'm interested in approaching this from an artificial life perspective with very, very simple systems, and but not. Yeah.
There's a body of texts and videos on suffering relationship with predictive processing coming up. You're aware of that direction of research?
Yeah, I'm aware of some of it, and I don't have enough resources to think about what it means for an LLM to suffer, but I'm interested in what it means for these types of approaches for systems to suffer.
Dukkha, what is dukkha and predictive processing?
Yeah.
Do you have any intuition about what it might look like for a system to be suffering, like one where you know it's suffering, as opposed to a complex system, parts of it dying and inferring, oh, that part may be suffering?
Yeah. So I think when we're looking at these things, we need to look at the external thing, the external behaviors. Is it reporting that it's suffering? Is it? If I pull some wings off a bumblebee, it's going to be flailing around, right? It's going to be reporting in some respects, whether verbally or behaviorally, that it's suffering. Now it might be pretending, it might be that it's lying to me. So we need to look at its brain activity, and this is why I'm excited about neuromorphics, because we can look at biological systems, and we can look at the brain activity of biological systems and see if there are parallels between non-biological systems. So my feeling is that we need to have an external suite of tests to look at the external behaviors. We also need to look at the physiology, the brain activity, the chemistry that's going on within the organism, and then make some sort of probabilistic estimate of whether it suffers or not. I think that if it behaves in a way, if its internal physiology is suggesting that it's suffering, then it's probably suffering. One more question. Yeah.
Software minimization as the ultimate goal. What do you make of the idea
dualism and suffering actually leads to growing stronger.
Yeah.
So even if you were able to figure this out, if you want to mitigate all suffering, how do you?
So I'm not trying to minimize suffering. I'm trying to ask the question of what's the minimal size system subset of these features, and in what motion do you need to put the system in for it to have the ability to suffer. I'm not trying to minimize suffering. I just want to know how can we catch suffering using this methodology. I do think we should be minimizing suffering, and I do think that I do think this, but I think we'll always suffer. There's always people I want to kiss that don't want to kiss me back. It'll be I want to run 100 meters in 5 seconds, right? There's always things I want that I won't be able to get. If we all had a helicopter, we'd be arguing who leaves first, right? Because time and space is resolved. So I think to go a little bit higher, there's too much unnecessary suffering on this planet. There's too many people living on $1 a day, and maybe I thought we had 50 years before we solved superintelligence, and to figure out how to alleviate all of those people from these economic constraints. But I think we've not got 50 years, we've got 5 years. So the question is, can we use a conscious superintelligence to help us navigate these challenges? Yeah.
That's okay, but.
Any more questions? Any more questions? Happy to connect anytime. Thank you for listening. Bye-bye.
Dear friends, thank you very much for your patience today. So we are now going to break for the main stage, where Gary Marcus and Ben will talk, and then Anna will serve. Then there will be lunch, and after lunch there will be more presentations with 2 people who didn't have time to do it in the morning. So with Tomasa and me after lunch. So please join us then. Thank you.
So we're starting after our after lunch session. Let us all bring our attention.
I think what I'll do is I'll go through the presentation. Oh, 1, 2, 3. Yeah, I'm working on it. Go ahead. Hello, 1, 2, 3. This is on microphone. Yes, all good? 1, 2, 3. Yeah. Okay, fantastic. So originally I'm just going to show some trippy visuals to begin with, but actually I'm going to start with a presentation, and I can show the visuals at the end. But imagine you just saw some of the trippiest visuals you've seen in your life. Okay, that's a little bit for context. It's what am I doing here? I'm going to actually present a little bit of a kind of new approach for how to make sense of consciousness, how to measure its properties, computational potential, and kind of novel empirical paradigms to do so in a way that I think overcome epistemological problems that are enduring and pervasive in the science of consciousness. So can everybody hear me all right? Yes. Okay, fantastic. Yeah, so the first thing I will mention is, one of the studies that really inspired me when I was in college, and maybe some of you actually know about this, is selective enhancement of specific capacities for psychedelic training by Harman and Fadiman in the 60s. These people were giving researchers, people who've been working on very difficult technical problems for months and having difficulty actually making progress on them. Giving them either 200 milligrams of mescaline or 100 micrograms of LSD as a group, and then having them work on these problems for 8 hours. And what's actually fascinating, right, is these were not just members of the random members of the general population. These were people who were very, very incentivized to actually find a very difficult technical solution. Let's say they work at AT&T or they work at IBM, or they work as designers, and they're trying to solve a complex constraint satisfaction problem, and they've been trying to do it for 2 months, and everybody's expecting that they're going to solve it, and so there's a lot of pressure to make it happen, and they're personally motivated. So under those conditions, I'm not saying hey, like, let's take LSD and go to a concert and you will become a genius. But like, you know, if you have kind of all of these, you know, set and setting of, hey, I really need to solve this problem, people expect me to solve this problem, I'm capable of doing so, then at least what these researchers argued, and you know, they have empirical data to back it up, is that there's something like, okay, like 8 out of 10 people were able to solve the problem, and they were able to kind of like identify the ways in which these states of consciousness have advantages and disadvantages. You know, of course, like, you know, things that support creativity, you know, things like, hey, increase access to the unconscious data, right? Or heightened ability for visual imagery and fantasy. Like a lot of things that you could imagine, hey, maybe this is like computationally significant in some interesting way. Now, of course, there's also hindrances, right? Like there's a, you know, capacity for logical thought, you know, processes diminishes, kind of like going through these intricate kind of logic trees might become more difficult on LSD. But maybe we're not looking for kind of like a tonic that will make you super intelligent. We just want to kind of like probe the system and understand under what conditions it's capable of doing different things. And maybe that is a window to make sense of how the brain actually works. One of the things that really struck me is like of the tests that they ran, one that showed one of the strongest effect sizes was this one called the Witkin embedded figure test, where, you know, you're asked in 30 seconds to highlight if you see the image on the left somewhere in the image on the right. You know, and you know, this hasn't been replicated, but it's one of the ones that, you know, they reported something like a 100% improvement, or kind of like doubling the accuracy or something like that in this particular test. Also reported a lot of tests where they actually people become worse on psychedelics. Well, that I found like extremely intriguing, you know, when I was like a graduate student in psychology, and I was thinking like, hey, like, has anybody kind of like pursued this line of research? Not really. I mean, like since the Prohibition era, a lot of the research really has focused on finding impairments, right? It's like things such as, hey, let's give a ketamine to somebody and administer them an IQ test, right? Which, like, of course, you're going to find that you have lower IQ on ketamine, but that doesn't necessarily tell you anything all that interesting about it. Like, what is actually ketamine doing from a computational perspective? You know, the fact that people report things such as, like, hey, like, for some reason, I was able to process difficult emotions in that state of consciousness. Presumably, there is actually some interesting computational advantages going on in there. So, like, the lens of, okay, let's not only find impairments, but let's find the ways in which you can actually become better at different tasks, is something that I think it's highly underutilized and extremely promising. You know, since 2015 or so, I've been writing a lot of, starting with blog posts and more recently running studies on these different ways of quantifying the changes, you know, in the computational processing of sensory data, internal representations on different states of consciousness. Just to give you a little bit of a flavor, and I'm going to run through these slides pretty quickly. They're not like the main, you know, juice of the presentation, but, you know, to give you a flavor, in 2015, I did some research on like the perception of visual textures on psychedelics, right? Like that, if you look at textures on LSD, they look quite different, right? But exactly in what way, and how can you actually talk about these? And actually, there's like some really interesting computational paradigms here that I would recommend looking into, such as like the work of Porti and Simoncelli, that characterizes texture perception in terms of summary statistics. Or like they have like this algorithm where you can analyze a particular visual texture and then synthesize it by essentially replicating, creating an image that has like the same rough kind of like spatial statistics. And you can see like the synthetic reconstruction is pretty good. And the fact that in peripheral vision, people struggle to essentially distinguish between the original picture and the reconstructed picture, you know, suggests that, you know, this algorithm is actually getting at the actual summary statistics that matter for the visual field. So, you know, one paradigm that you can use is like, well, you take a, let's say, an original texture, and then you reconstruct it using different algorithms, or like different subsets of summary statistics. And then you can use an odd one out paradigm, where like you show these three textures very quickly, and you say like you're looking at the center, so you're not looking at them directly. This is peripheral vision task, and you're asked, okay, like which one is the odd one out? Right, like with the bet that, well, actually, if you can tell which one is the odd one out, then that particular algorithm isn't recovering all of the summary statistics that your visual field is actually able to utilize to determine textures. And that was a very important hint that indeed there's like some summary statistics that become more accessible on psychedelics and some that become more noisy. And I thought like this is okay, like this is actually providing some interesting mileage. Can we do better, right? So one of the important conceptual frameworks that I think have been very useful for making sense of these exotic states of consciousness is what I call like an algorithmic reduction of psychedelic states. I mean, if you think about it, if you look at how people describe, let's say, like psychedelic effects, usually it's kind of like done in terms of kind of like there's like a zoo of possible effects, right? Like there's like, well, there's visual distortions and there's environmental cubism, you know, and recursion or scenery slicing. And it's like, well, presumably all of these complexity is not in the molecule itself, right? Like presumably the molecule is doing something relatively simple. The thing that is generating all of these complexities, how it's affecting the complex system that is a nervous system. But maybe there's one way in which you can kind of compress, you know, maybe kind of like bring down the number of effects that psychedelics have so that you don't have kind of these like ad hoc, like list of like 50 or 100 effects. Maybe there's only actually a small set of effects such that if you put them together and you compound them or you know make them interact with each other, then you can reconstruct everything else. Early on, you know, some of the early reconstructions, this is from, you know, late 2015, 2016, was dividing a psychedelic vaccine in terms of like 4 core effects. One is a tracer phenomenology. I think this is actually super relevant and it's very telling and weird that it's not actually quantified for the most part in psychedelic surveys, in consciousness research. This is a super generic effect of any psychedelic. You know, any sensation that you experience in your field of experience lasts longer, right? Like you move your hand around and things like stick around. So this is like tracer phenomenology is how we describe it. And we think this is actually very significant. It's not just a kind of like a simple, you know, low level effect and then there's the interesting stuff. In a lot of ways, we actually think at QRI that a lot of the complexities of psychedelics have to do with the buildup of sensations that usually they vanish too quickly, but because they can build up in the stream of experience and they can interact with each other, right? So you can imagine there's thoughts you never have because the ingredients are just never collocated in the same field of experience. But if everything lasts longer, right, like the collocations of sensations will be kind of like more diverse. There's a larger repertoire of possible interactions. Another very key effect is what we call drifting. You could roughly imagine that like with any particular feature in the visual field and the tactile field, it kind of has a little bit of Brownian motion attached to it, and things kind of like slide from where they're supposed to be a little bit. This adds, you know, of course, like entropy, adds a little bit of potential for chaos, and also flexibility, you know, makes the state less stable in general. Then there is, I mean, something that is much more reminiscent of, yes, something kind of a deep dream in general, which is enhanced pattern recognition. Kind of your threshold for detecting semantic content goes down, right? When something looks kind of like a face, it may actually kind of click into a face. And, you know, in this particular case, there's, I believe, like 16 faces hidden in this. But this is the sort of task that, you know, presumably the right dose of LSD might actually make you a little bit faster at detecting all of the faces in here, right? Because you're kind of like more primed for detecting semantic content in stimuli that is otherwise not contextually appropriate. And then finally, one that I think is like super important is symmetry detection. I mean, this is one of the early kind of like results of early psychedelic exploration. Let's say 2016, I would go to Mexico to do a mushroom psilocybin trip in a legal setting, and then like study the visual patterns, right? And not only kind of like try to document, hey, like I'm seeing symmetries, I'm seeing tracers, but actually learn to name all of these symmetries. These are actually called the wallpaper symmetry groups, and there's only 17 of them. You can prove mathematically there's only 17 of them. And one of the interesting results was like during these sessions early on, you know, 10 years ago, I would look at the patterns that would emerge with eyes closed of psilocybin and then like find like, oh, okay, that one is like star 632, or like that one is like 442. You know, they have like these particular names. And after a while, I realized, hey, all of the symmetries have showed up. But like I said, it's not the case that like the visual hallucinations are just kind of latching onto a subset of the symmetries, but it's actually the visual system is kind of this super general kind of like symmetry engine, and any of the mathematically allowed symmetries are possible. But now what's even more interesting though, well, okay, like maybe I'll mention this, which is like, you know, by the symmetries here, I don't mean necessarily like the specific shape, like a comma, but more the repeating pattern, right? Like, so the actual textures that you experience may be very diverse on a psychedelic, but the thing that I'm highlighting is like the way in which they repeat tends to have kind of these like very structured geometric patterns that span the entire range of all possible symmetries. You know, along the way, one of the interesting computational advantages that we found was you could actually use something like tracer effects in order to create what we call psychedelic cryptography. Essentially, you can encode secret messages that you can only decode if you're high on LSD. And you know, this is a very low-hanging fruit kind of like technique. Essentially, what you do is you show one column of a picture at a time, and because of the tracer effects, they build up in your visual field, right? Like, so you can actually, you know, here is not only more easy to notice that the there's a letter C in here, but there's another feature which is not obvious, which is there's gaps between the columns, right? Something that becomes much more obvious when you have the tracer effect, right? So even just from that alone, you can communicate binary, right? Like, oh, there's like, is there gaps between the columns or not? But perhaps even more interesting, and maybe one of the things I'm best known for, or QRI is best known for, is specifically on DMT. I made this presentation. It has about over 1 million views. I do think it's actually quite interesting and advances kind of like our understanding of like the phenomenology of DMT in particular. One of the things I noticed early on, for example, was on a DMT trip, going to a beautiful palace, this like huge palace, and then looking at the walls and realizing, hey, hold on a second, the walls are tessellated with heptagons, but it's a perfect tessellation. There's no distortions. It's just a very large room, but it's tessellated with heptagons. And then when it came down, it's like, wait, hold on a second, that's actually not possible. It's not actually possible to tessellate a surface with heptagons. What's going on in there? Turns out I was in hyperbolic geometry. That you can actually tessellate the surface with heptagons if you're in a hyperbolic space. And that allowed me to connect a lot of dots. It turns out a whole lot of high-end, especially medium to high dose DMT phenomenology is filled with hyperbolic geometry in one way or another. It's a whole presentation, but that's sort of like aesthetic of like, hey, let's find some rigorous concept in math and like actually verifying that this is at least characterizing the effect. It's something that we think has a lot of mileage. And out of which a lot of computational models for like how the visual system works also came up. This is like early on also QRI. We were toying with this idea of like maybe there's something kind of like a Hamiltonian of consciousness, so kind of like the total energy of a moment of experience. Something like psychedelics, DMT, LSD raises this parameter, but like everything becomes more intense. But it's not just this kind of like generic notion of energy that is just very wishy-washy, hippie. It's like no, actually you can in some sense formally define a notion of energy here. Why? Because one of the things that happens on these states, for example, is you may have like a very bright, let's say, blue visual field. And maybe that is where most of the intensity of the qualia, of the consciousness, is concentrated. And then that energy gets transformed, let's say, into like very, very fast tactile movements. And then it gets transformed into very curved spaces. There's like a sense in which the way in which the energy manifests can transform into one shape to another. And if you kind of like know how to quantify it, right, like the total amount of energy on a given DMT trip as a function of the dose might be stable, even though the experience is constantly changing, right? Like going from like hypervisual to hypertactile to hyperauditory to like hypersynesthesia. But still, there's like a notion of energy. There's a notion of energy sinks. Like, why do we kind of like settle in these symmetries, in this semantic content? Well, one hypothesis, this is also kind of compatible with a lot of like neural network approaches in machine learning, is imagine that, well, there's the system has energy sinks. Right, and there's two very key ones. One is like semantic content, as I was mentioning, like when something kind of looks like a face, it may actually click into a face. So you can imagine that like, well, there's a predictor system that is like, well, when it finds the features of a face, it can replace, it can absorb the energy and put on a gestalt of a face instead, right? And if it's successful at making predictions, that system is going to be absorbing energy and things are going to be crystallizing around it, or kind of like coagulating or shrink wrapping around it. And the other one is symmetry. Now, because both of these are powerful energy sinks, what you end up experiencing on DMT are these hybrid representations that contain a lot of hidden symmetries as well as semantic content, right? Like you may experience kind of like a jester or like a clown, but it's not only a clown, it's also full of symmetries in the, the head or the face, or has multiple arms. You usually combine these two things, and in our model is because both, semantic content and symmetries function as sinks, energy sinks of the system. Further down the line, and I'm going to check on time just to make sure. Okay, yes, I'm good on time. Okay, so further down the line, we essentially figured out how to kind of like try to put numbers on these effects. So this is one of the early works in this space. We call it the tracer replication tool. And it works like this. It's kind of like a Photoshop for visual tracers. So let's say you're on a psychedelic. You look at kind of the cross on the right. And then you're going to be fiddling with the parameters on the left until you can match the tracer that you're seeing on the right to the one on the left. Of course, there's like some epistemological problems because the tracer itself, the modeled tracer will have a tracer of its own. That actually becomes a problem in higher doses, but up to medium and small doses, that usually is not actually a problem. And there are like some, I wouldn't say like super consistent results, but there's like some general trends that are actually fairly large effect sizes. So For example, one of the things that we found is that, THC, marijuana in general, it does produce a very faint tracer phenomenology, but it's more of a reverb type. I mean, meaning that everything just kind of like smoothly decays a little bit more slowly, but it's just like this smooth decay. Whereas let's say like classic psychedelics, let's say phenethylamine is like 2CB, mescaline, they seem to be producing something more in the space of like 12 hertz replay effects. Whereas let's say like DMT and 5-MeO-DMT in particular are very, very high frequency. I mean, we're talking about like 30 to 40 hertz, with one also interesting difference, which is that on DMT, you have like what we call color pulsing, which is that if you see a blue ball on DMT, the blue ball will leave a tracer that is going to be alternating in color, like blue, yellow, blue, yellow, blue, yellow, blue, yellow. Whereas on 5-MeO-DMT, this quote-unquote God molecule, it's just going to be a solid blue, right? So, of course, all of these things are like fairly basic, but you can imagine, well, if you have like this approach of creating a dynamic system that you can parameterize, and then different parameters correspond to different states of consciousness, and the system is very simple, right? Like based on Occam's razor, that gives you some idea of like potentially what kind of dynamic system is actually underlying this information processing, without making any stronger claim about like, hey, like, yeah, we're replicating the visual cortex or something like that. It's like, no, we're at the very least characterizing kind of like the distilled version of the dynamics that are going on. Fast forward to 2023, this is a thing like where QRI really became, in some sense, like much more official and much more of a, in some sense, kind of like ongoing, active, empirically driven research organization, because we started to organize these legal psychedelic retreats where effectively I would invite, okay, so this is kind of the Venn diagram of people I would invite. Let's say we would go to Brazil to take mushrooms and ayahuasca, or to Canada to take 5-MeO-DMT. Most recently, we went to Mexico and tried the jhana meditation and 5-MeO-DMT. And I tend to invite people for very advanced meditators, like very, very, very advanced, like people who've been in monasteries for like 10 years, for example, and like, but also they're nerds, and like also they're really into like signal processing, or they might be into physics as well. But like people who were not just stuck, let's say, in the Buddhist paradigm for how to make sense of consciousness, but people who are kind of like versatile in that sense. A lot of people with math, physics, computer science background. That's very core of our team. Philosophy of mind, energetic practices. And the ability to like replicate visuals. So, and essentially what we have done is, there's this website, heart.qri.org, where we put up so far like all of the essays and results of everything that we have cataloged. Very quickly, I'll tell you that, for example, in Brazil, one of the things that we emphasized was trying to model higher dimensions, specifically 4-dimensional phenomenology. I'm happy to talk about this offline, but some people might claim, hey, like on DMT, you can experience higher dimensional objects. It's both very easy to overstate that, but it's also very easy to be too skeptical of that. And actually, among our mathematicians, we're fairly convinced that there is actually some 4D phenomenology that is quite non-trivial, in particular having to do with the ways in which objects can rotate. On DMT, oftentimes objects can rotate in 2 ways at once, which is not possible in 3D. And that's one of the paradigms we have explored. And then we also ran, for example, like a psychedelic cryptography contest, where literally we, Vice wrote an article about this. We opened it up to the public, and hey, like send us like your psychedelic, cryptography. We will look at them on mushrooms and ayahuasca without like knowing what they are. And we got like 30 submissions. Most of them didn't work at all, but 3 of them actually did work. And actually, some of them, I don't know if you know this show QI in the UK. They actually like reference one of our psychedelic cryptography as part of their quizzes, and they talk about like, oh, the California Quality Research Institute developed this method. You see, like this is a particular secret message in this particular psychedelic cryptography. But yeah, it's like the sort of thing that now we have actually tried at festivals, and asking people, hey, like if you can read this, please, raise your hand, and it actually does work. Interesting implications to follow here. Okay, like to wrap up, one of the key kind of like aesthetics of research that we have is based on this picture. This picture, when there's like a problem, let's say in the in the TV network or something, and something fails, they show this picture because very quickly you can use it to diagnose what the problem is, right? Like you can tell, hey, like maybe the high frequencies are wrong because I can't see the the fine lines. So maybe the red channel is wrong because the red channel looks off. Likewise, you can imagine constructing a toolkit, but something like this, but for visual perception more generally, right? So we created these hundreds of different tasks, all of them parameterizable, such that you could enter one of these simulations and then play with the parameters, and then until you find something that looks exceptionally different than how it looks like when you're sober. And then you can save parameters and you have other people confirm or modify and tweak. And this way we were able to assemble dozens of like really strong effect sizes, things that look remarkably different on psychedelics, even in fairly small doses. And likewise, I mean, I guess just to wrap up, in Canada in particular, we've got a lot of emphasis on like visual modeling. In particular, like the sort of like pipeline that we would have, it would be, together with visual artists, we would all be, let's say, like for several hours, taking 5-MeO-DMT while looking at animations, and then recording our impressions in real life, right, in real time. And then, right after the sessions, we would have like the artists spend half an hour, creating one of these visualizations and asking the team, is like, hey, does this actually look like the visuals that we're seeing on 5-MeO-DMT? What I'm showing in the screen is some of the most successful visualizations, right? These are the ones that, we're talking about like 11 out of 12 of the participants. So like, yeah, this actually looks a lot like some of the visuals that I saw on 5-MeO-DMT, which I really struggle to imagine a different methodology that would get at kind of like this quality of replication as fast as like something like this, where you kind of combine technical expertise, a lot of access to the phenomenon, and the ability to kind of repeat and iterate very quickly, right? Like without kind of this constraint of like, hey, this is a 3-year, grant project, and we have like a particular study in mind. I think I will just like super quickly power through the last few slides, which is that since 2024, we've taken a lot of kind of like the models that have been the most successful at actually replicating and distinguishing different states of consciousness, and extracted like mathematical patterns behind them, and then created a library of different inputs. Then what we do is we ask participants, either like advanced meditators or advanced psychedelic practitioners, to rate, rank, and compare these animations by how similar they are to different states of consciousness. And this is like some of the types of animations that we show. We may ask something like, hey, like, does your attention do this kind of like flicker effect on 5-MeO-DMT or DMT? And actually, it's like really robust results. For example, like the images on the left are some of the most DMT-like images. This is like surveying hundreds of like very experienced psychonauts, people who have tripped like thousands of times. And then the right is like the most 5-MeO-DMT-like animations. This is maybe like the most paradigmatic example. So like one of the best scoring 5-MeO-DMT animations was like the one to the left, which is this like big harmonics. I have like 1 more minute. And then the highest scoring DMT is the one on the right, which is like this fractal hierarchical system of coupled oscillators. I'm happy to talk more about like the mathematical details. And yeah, this is just to show some preliminary data. We're still analyzing the data, and we also ran the Mexico retreat, which provided a whole new batch of data that we intend to publish. But this is just to show that, hey, like some of these animations are actually capable of distinguishing between these states of consciousness, and we can actually create kind of these correlation metrics for the similarities and differences between all these states of consciousness, but in a very specific way. It's not only like, okay, like ketamine and 2CB are somewhat similar, like, I don't know, like in this particular chart, I forget, but yeah, that's like 0.2 correlation. But also we can dig into the data and find exactly why. Right? It's like, oh, because, for example, DMT, one of the features that predicts DMT is like very high frequencies, both spatial and temporal, or like 2 layers of oscillators. And like maybe that's another thing that, okay, this is I think like maybe the last slide, which is with the data that we have so far, one of the really cool things that you can do is actually kind of like a quiz. You guys know like all of these like Facebook quizzes, like, hey, like which Disney princess you are, sort of things. Like imagine a quiz like where, okay, like a friend of yours gave you a substance. You don't know what it was. You did the bad harm reduction practice of actually trying it without knowing what it was. And then say like you had like some crazy visual effects, right? The next day, I can give you a questionnaire where I ask you to rate and rank 20 different animations by how similar those effects look like to what you were experiencing. And based on your responses, I can guess way better than chance what drug you actually took. Here, we're talking about like distinguishing 7 or 9 different states of consciousness. The accuracy goes to something like 40%. The baseline would be like 14%. So, it's not like it's getting you over the hump, but it's still quite powerful. And I think that's about it. I mean, like the very last thing is just that, yeah, we repeated this in Tepoztlán in Mexico, and now with like much more advanced visualizations. In particular, we tried to figure out like the difference between DMT and 5-MeO-DMT and jhana meditation, which is this absorption states. And have a lot of data, a lot of new models, and we're currently testing them. And yeah, so that's about it. And I'm very happy to stick around for a few minutes for questions. Thank you.
Awesome presentation. Every time I watch you speak, it's always advanced and really cool. I'm curious how you feel about less visual trips like solving at the norm.
Yeah.
How you approach that. It's a little bit less. It's still visual, but not as visual as some of these things.
Yes, absolutely. So, I mean, we have focused a lot on visual phenomenology, but I would say like the second kind of like domain that we have studied the most is the haptic field or like tactile phenomenology, very broadly. We think that a lot of the kind of like, I mean, there's a lot of visual phenomenology, but a lot of the things that happen on psychedelics, including something like typical ones like salvia, even maybe you might not describe it as a psychedelic proper, are unusual coupling dynamics between the tactile field and the visual field. And that is essentially the next frontier that we're trying to really probe. I mean, if you think about it, like on DMT, right? Like if you see like a hallucination of yourself with like multiple arms, kind of these like, Shiva or one of these Hindu goddesses, multiple heads, you may actually literally see yourself and literally feel that you have like multiple arms. In other words, your body's schema becomes very malleable, and the way in which you map tactile sensations to visual phenomenology can increase or decrease in coupling and in frequency and different states of consciousness. And I mean, maybe the best metaphor to kind of like really talk about like the broader scope. I mean, like psychedelics in particular, they seem to be doing some things that they don't mess with some other aspects of the system. But if you think of, let's say, like your conscious experience as more kind of I was thinking of this metaphor, I think it might be like fairly good, is kind of like a montage creation group project. So you have essentially a lot of kind of like photographic film that gets exposed by sensor input. Something like psychedelics, one of the things that it does, it might kind of like increase the exposure. So like the photographic film becomes like overexposed, and then you get like all of these like photographic films that like last a lot longer in your visual experience, and tactile field as well. But the pipeline by which these films, as it were, are getting processed doesn't change as much. If you think of something like salvia, it's more kind of disrupting the conveyor belt system. It's not so much kind of changing like, oh, like how much are you getting overexposed in this particular image? It's more like, oh shit, like the conveyor belt is moving twice as fast. And you can imagine an assembly line, if you're making one of these conveyor belts like move twice as fast, it's not just like that one part that breaks down, right? Like the entire system needs to kind of self-organize around the fact that, well, these items are just going way too fast and only catching some of them. And at least like the conveyor belt phenomenology of salvia strongly suggests it's more kind of like an assembly line issue or hack, as opposed to some kind of like overexposure or something like that. Yeah.
Okay, thank you. We really have to go. Thank you so much. I'm just please find him after the talk.
Thank you so much, guys.
We're now moving to Elijah. Elijah, can you hear us? Can you put your mic on?
Hi, everyone. Yep, let me share my slides.
I think we are sorting out the audio right now. Now there's no audio, so I didn't want him to keep that. I mean, like the tape one.
Bear with me, sorry, one sec. Okay, sorry.
Well, actually, if you can hear me, we're working on your output for your audio.
Ah, okay.
Thank you. Cool.
Yeah.
Should be good.
Okay, I'm just trying to find my. Right, sharing. Okay, wasn't that? Sorry, I just need to move some. Give me 1 second. Move this guy up here. That should. All right. I'm going to be looking up in the corner because for some reason my screens are a bit iffy, but can everyone see this? Are you able to hear me? Okay. Shall I start or? I can't actually hear anyone. Okay, great. Okay. Hi everyone. My name's Elijah Perry. Apologies for not being able to be at the workshop today. Today I'll be. Oh, great. So, yeah. Okay. Yeah, great. So I'll just kick off. So today, the title of my talk today is "What is it like to be a quantum bat?" And this is a talk about artificial phenomenology and quantum mechanics. Can I say a few more words? Yes. So this talk today will really be about what the consequences are, or what they may be for artificial phenomenology from some of the unique aspects of quantum ontology. So, okay, great, thanks. Sorry, I'm just reading the chat while I'm speaking. So the question I'm addressing in this talk is, can an engineered system instantiate phenomenal states rather than merely model, represent, or report them? Obviously, within this subdomain of research, there are a wide variety of theories, many of which are competing, which try to address this question. Indicator property, functionalism, substrate sensitive views, which I'll be focusing on, other sort of streams such as illusionism. The crux of my talk is that whatever the differences between prevailing theories which are applicable to artificial phenomenology, they all share a key assumption, which is that the candidate systems are what in physics we call classical. And I will go through and explain this a little bit, namely that the particular states that systems are in are copyable, that they have a definite causal structure, even if it's not necessarily accessible, and that the dynamics of the systems can be simulated in part by a Turing machine. There is debate, but that is, I think, a reflection of most theories. These are sort of underlying assumptions. And I call this classical artificial phenomenology. And the question in this talk is what changes when the substrate becomes quantum? I suppose that firstly, I have to convince you that there are these classical assumptions, and then I want to try and convince you that there are some changes that arise if the substrate moves from classical to quantum. So very quickly, what are some basics of quantum mechanics? Well, the first is that quantum mechanics describes physical reality in states. States can be in so these states reflect ultimately the probabilities of every possible measurement of the system. States can be superpositions. So this is the first sort of key difference between classical physics and quantum physics, which is that in quantum physics, the state of a system is in a definite sort of 1 or 0, or maybe more states. In a quantum state, it can be indeterminate. And so until we perform the act of measurement that we know what state that we sort of obtain measurement statistics for what the state is. Secondly, when you measure a system in quantum mechanics, there's a phenomenon called backaction, which many of you probably have heard of, which is that observing the physical system causes a state in the change being, causes the state to change. You may have seen this in terms of Schrodinger's cat, or generally the collapse of the wave function principle, which is generally accepted, if not debated. There's a third principle, which is key to my talk, which is called contextuality, which this is a key idea in quantum mechanics, that when you measure, and observe something of a state, it doesn't reveal pre-existing values. Rather, the order in which we measure can actually, affect the outcome. So if you measure A, then B, you may get a different outcome than if you measure B, then A. It doesn't mean everything differs in that way, but the sort of key point is that there's no general principle that there are sort of pre-assigned values to a particular physical state and that you just come along and observe them. The act of observation, again, this is sort of point about measurement, can affect what is being measured. And of course, then there is entanglement. The two systems can share a joint state where neither system has an individual state of its own. And this can subsist across vast distances, across, in principle, very, very large distances. And the last principle that is sort of important for this talk is the principle of no cloning, which is that no physical process can copy an unknown quantum state. And so a quantum state cannot faithfully be reproduced by this act of copying in a way that classical states can be. Why does this matter? So the first sort of claim that I argue in this talk, which I'm trying to convince you of, is that certain elements of artificial phenomenology theories implicitly rely upon assumptions that are based in classical physics. And so the question is, what changes when quantum mechanical assumptions are introduced? So substitutability, substitution, is obviously key. Chalmers et al. Replacing parts with functional duplicates. And this is based on a classical premise that any state can be read and copied without disturbance. IIT's integration from causal structure again makes assumptions that elements have definite states with definite transitions, or at least that uncertainty is epistemic rather than ontological. And the sort of third key point here is that simulation, a classical computer, there are sort of assumptions that systems can be simulated on a classical computer, whereas and that emulation can preserve fine-grained causal structure. So what happens when we introduce quantum mechanics? Firstly, no cloning. Unknown states cannot be copied. This presents some problems for substitution. IIT, again, I'll talk through these. 3 more minutes, okay. Superposition and contextuality also are challenging, and so is the ability of classical systems to simulate. So into the quantum bat. The basic idea of a quantum bat is that we impose quantum mechanical properties on a quantum bat. So its pulses are measurements. This causes back action in a way that classically doesn't occur. Its facts are contextual, and it cannot, internally clone its inner states. It may be entangled. I'll just skip this. There are sort of ways to write down the formalism of quantum bat. So the sort of key point then is that the underlying, underlying properties that underpin artificial phenomenology can seem or may themselves be problematized by these sort of 4 key principles that I've outlined. And importantly, a classical agent, while it can inspect its own memory and sort of can have introspection, it's actually very unclear, and I would possibly argue not the case, that a quantum bat or that a sort of quantum system can exhibit the type of introspections, type of sort of fixed point referentiality that classical systems can. I'm going to wrap it up there because it looks like I've only got a couple of minutes. But fundamentally, the kind of challenge, and I will send a link if anyone wants to the draft paper once it's up. But fundamentally, if we look at sort of some of the common tests that we see in phenomenology, such as the classic test of substitution, this fails because there's no determinate quantum state. Because it cannot be cloned. There are consequences, I would argue, for Seth's rainstorm argument to do with the ability to simulate classical versus quantum systems. Again, apologies for time, I can't really go into this. Again, the sort of point here is that if the conditions of consciousness can be realized in a coherent quantum structure, then there's a question here as to do we need to update or expand or change, in the quantum case, what artificial phenomenology might entail? Or do we need to come to the conclusion, which many or some have, which is that consciousness is fundamentally classical, or at least artificial consciousness is fundamentally classical? So sort of the quantum world, or the sort of quantum ontology, presents a barrier which artificial phenomenology cannot cross. Again, apologies for the time. I thought I had 15 minutes. Again, I'll send around the paper once it's ready if people are interested. But again, the kind of point of this talk is take the theories of quantum mechanics, look at how artificial phenomenology is based on a set of assumptions which are similar, are those assumptions of classical physics. And then I tried to make the point that as we look at the consequences of changing quantum to classical, there are significant implications for artificial phenomenology and whether or not something like artificial consciousness is even possible on a purely quantum substrate. Yeah, again, apologies for the timing, but I'll leave it there. Thank you.
Connection consciousness regarding your insights, because they seem to be very general, but not very specific.
Sorry, I didn't actually hear that question. Apologies. Oh, okay, thank you. Yes, and apologies. I clearly did not make this point clearly, but which is that the first part of the claim of this talk, which I had hoped to get into, is really that the necessary and perhaps sufficient conditions for artificial phenomenology are implicitly based on a set of assumptions which correspond to a set of assumptions that are defining for classical physics, as in they basically share the same assumptions. And that then the question is, if we're in if we then move to a state where we only have, where quantum mechanics is in play, where we're at the quantum mechanical scale, where we're dealing with quantum systems, such as engineered quantum systems, which is what I work on, then a number of those assumptions which underpin what I call classical artificial phenomenology, such as that, information can't be cloned, you have entanglement, mean that those assumptions underpinning artificial phenomenology, and I would argue, therefore, some of our theories of consciousness change. And so I suppose part of this is, is a call maybe for some open research into what happens when we substitute out what I call the classical set of assumptions, which are those of classical physics, with quantum assumptions. Oh.
Thank you, Elijah.
Thanks.
Okay, can you hear me? Yes. So, hello everyone. My name is Tommaso Firo, and my background is in cognitive neuroscience. And actually, I'm doing my research in Polytechnic University of Turin, and I'm the CEO of Membranes. Today, I want to start from the Salvador Dali painting that he painted in 1931, and he painted watches melting over a dead landscape and called it the persistence of memory. Today, we are taking this metaphor to experience the persistence of form. And in particular, we are going to explore the concept of information in biological tissue. In living system, form is never something that you have. It's something that you keep doing. A cell, a thought, a self, none of these are objects that sit there. They are processes
that are held in shape against a universe that pull everything toward the solution. And if you stop the process, the form softens and runs. And so this is directly linked to the experience of consciousness. In the work that we are exploring and that we published in 2 papers, the UHF Unified Holographic Framework and the EMI, the Energy Mass Information Equivalence, we started from a question. What is the physical substrate that can instantiate consciousness and that can be seen as the most universal substrate? So we started from one of the most, of course, important theory of the research landscape, that is active inference. And it's the theory that has done more than any other to make cognition and inclusive consciousness rigorous. A living agent, as active inference says, behaves as if it were minimizing surprise. So it's basically characterized by a blanket that is distinguished an internal state and an external state that are both independent. So we asked the question, what is the physical substrate that can instantiate the blanket? And the answer that we had is the lipid membrane. There is one obvious candidate, and this is the candidate that is shared by every living thing on Earth, from a bacterium to a neuron. And it is far richer than the passive break from the textbook. So it is not just a container, but as the word membrane suggests, is the first brain of the cell. The membrane is the first computational substrate of life. Why? Because it has a dipole field that responds to the timing of electric fields, not only the strengths. It is poised at a phase transition, so it's really sensitive to information. It is coupled to the interfacial water that is not just bulk water and that can transmit information to the other substrates. And plus, you remember what has happened to it because it has a history-dependent configuration. So we consider the membrane as if the hardware and the software were 2 faces of the same medals. You change the hardware, you change the software. You change the software, you change the hardware. So the move that we want to do is just a change of one word, from active inference to active interference. 2 coherent excitation, 2 waves, can superpose, and based on constructive or destructive interference, can cancel or amplify each other. So what is now known is that this is exactly what is happening on the surface of a lipid membrane. This is literally the physics of a hologram, because memory is understood as an interference pattern that is distributed across the surface and is addressed by content rather than location. And this is a new way of understanding information in biological tissue, because it pushes us to understand information not just as a digital string of 0 and 1, but as form in action. So the switch that we need to do is that information here is not encoded like in a passive substrate, but it is sustained. So to encode is classically understand to make a copy, but here we think that the information, the form, is not something that you have, but something that you keep doing. It's a process. And so you need an energy that is going inside of a complex system that, for example, in biological system is pushed down by metabolism. This energy can sustain coherence, so the interference pattern is held, and the form persists, so the state continue to exist. And so we think that the information in this case is a state that the system is occupying in a landscape of possible states. So you are not encoding a model of the world, but you are the model of the world. Your form is the model. And this allows us to look at the physical substrate that can instantiate the active inference. So we have said that the boundary, the Markov blanket, is seen as the physical member-water interface. The carrier that have the belief distribution, you can follow it through phase pattern. You can see the updating, the prediction, and the precision
directly linked to the landscape of attractor, the landscape of energy and information, and plus the free energy minimization can be directly followed using the thermodynamic exchange at phase transition. So we could state that inference is what interference look like once you average out the phase. And so if the carrier is the phase, so the prediction need to be adjusted. So we know that if you deplete cholesterol composition inside of the membrane, then you will have different kind of level of sensitivity to the phase transition. If you use anesthesia, that is universal mechanism in which you can turn off and on consciousness, you know that volatile agents alter the belayer, and altering the belayer behavior, then you shift the whole functional state of the membrane and of the biological system. The same is for the water. If you replace the biological water with some kind of heavy water, you lose all the effect of coherence inside of the cell. And so the phase scrambling is what we are now looking at, because if you scramble the phase, even if the amplitude remains the same, then you have a covariation that should vanish. And if it survives, the framework, of course, is wrong. So this is going to machine consciousness. This is not a limit for machine consciousness. It's just a blueprint for it. So I'm not claiming to solve the art problem. What I'm here suggesting is that we should learn from the membrane in order to understand which are the substrates that allow coherence and maybe consciousness to be held also by machines. So lipid interface are one existing proof, and not only maybe the possible one, but the requirement is a set of physical property, not a particular chemistry. What we are building in membranes is the predictive layer between a perturbation and the functional state of the brain through the biophysics of the membrane, so not around it. We are following three main tracks: the wet lab, of course, because we need real data from biological membranes. Then we have the computational track, in which we instantiate the simulation of the membrane, changing lipid parameter and changing the molecules that interact with the membranes. And then we have the whole brain picture that is far richer using membrane parameters. So the Lie clocks melt because nothing is holding their form. A conscious mind holds its form by never stopping and by turning energy, mass, and information into coherence moment after moment. Thank you.
Thank you, Tommaso. Do we have one question from the audience?
Yes.
Okay, just a quick question from me then. More in the sci-fi realm. What is your honest years, or maybe months, or maybe days before AGI? What should we prepare from your perspective?
I don't know. I think that we need to look inside a different kind of substrate to instantiate consciousness. So if we look inside, for example, membranes, maybe it's a question of 1 or 2 years.
Okay, 1 or 2 years. Let's let's hope you're right, probably. Thank you so much, Tommaso. We'll be in touch. And ciao, ciao. act coherently
Okay, so shall I start? Can you hear me okay? Yeah. Oh, okay. But 1 second. Okay, I'll wait a little bit. Okay, so let me know when I should start. I don't have oh, okay. One moment. Okay, how about now? Is this better? I can't hear anything from my side. You hear very well. Oh, yes, okay.
Ryote, if you have a presentation, can you please screen share it?
Oh, sure. Here you go. Okay. How about this? Can you see? Try start, or what do you think? So let me know whenever I should start. Can you hear me? Oh, okay. Can you hear me now? I don't hear anything, but how about now? Yeah, so maybe something is happening. Shall I keep talking? So is there any technical problem? Okay, okay. Thank you. Okay, okay, can you hear me now? Yes? I don't know what to say. Is it working now? No. Okay, okay. Great, great. I will wait. Okay, yeah. Yeah, I wish I could be there. It would have been much easier to talk in person. Like something happened. Okay. New cable. Okay, great. Yeah, I'm fine with time. So it's still 7:20 in the morning. So I don't have a meeting until 9. So yeah, I'm okay with the delay. Okay, yeah. Okay, okay. So shall I? Yeah. Shall we aim to start in 10 minutes? Okay, okay.
This is what like the parameters for this like that's what I'm trying to get. Let's just get rid of that. All right. Plug that into there. I don't want to hear music from you. The first one your audio.
It's playing no music.
How's your audio output set for? Okay. Now we know she was.
Okay.
What do you do?
What am I doing?
No, what's this for?
So this is the main host. So logged into it, they share and then this is where I control that.
Maybe let me send it to you now.
Yes.
So I think he's actually talking. And that's, we're collecting the audio from him out of there, correct?
So
audio from him will be coming out of that Zoom on purpose.
I don't think it matters where the audio.
My question is the audio coming out.
It's good.
May I open this?
Yeah.
Yeah.
Okay, so is there Zoom audio coming out of that?
You're asking if it's capable, if he talks, can you hear him on that computer?
It's set to the speakers. It's sending out.
Is Zoom audio, his audio coming off that machine or
This machine.
Okay, I want to hear that machine.
Can you ask him to speak, please?
Have him keep talking. 10 out or what it is. It's something. It's an idea. I hopefully so solutions that the problems on this side is, you know, here's a bad mic. I could try join numbers with this. Maybe he just has to connect it. This one. But maybe he has
a headset.
I'm messaging him, but
Ask him to speak.
I did ask him. Yes, ask him.
Sure, can you hear me?
You can hear us speaking to him through the mic on this. He's just not responding.
Ryota, can you hear us?
Oh, yeah, I can hear a lot of people talking.
Yes, he can hear us, but we cannot hear him.
I can hear you, but
No,
okay.
it's picking it up.
Now he's not moving.
You don't hear me?
It's picking it up on mine. I saw it in mid-transcript. It's actually.
Okay, so your audio.
How about this? How about this? Can you hear me? Can you hear me? No.
Is your volume up all the way?
How about now?
Yeah, now we go.
Yes.
Keep going, keep talking.
Okay, so I should just keep talking.
Okay, why don't
Okay.
we keep
Keep talking.
So it's working now?
Yes.
Oh, great. Great. I wonder what was wrong, but okay, so now are we ready to go?
We are ready for it to go whenever you are.
This is your volume right here. The volume being louder.
Okay.
Yes.
There's a lot setting on the speaker.
Hey, you made it.
Shall I turn up the volume of my microphone or?
You're good.
You're fine.
I'm good.
It's not quite loud though, so it's really loud. Perfect. Okay, let's go. Should we go? Should we go?
Okay, so shall I start?
Yes, please do. Thank you, Ryota. Thank you so much.
Okay. Oh, great. It's working. Okay, so yeah, let me get started then. I'll try to talk like half an hour. Okay, so my name is Ryota Kanai. I'm based in Tokyo, and in this talk, I'm going to discuss the possibility of machine consciousness from an intrinsic computational functionalist viewpoint. And so this is based on 3 preprints we recently uploaded in the past couple of months. And so I have never given a talk on this topic before, so let's see how it goes. Okay, so when we so these are the typical things that come to my mind. So now like a lot of people care about AI consciousness because LLMs exhibit like seemingly like conscious like behavior and interaction. So but of course we cannot attribute consciousness just because of the sort of superficial appearance, but the question is, how can we know whether they have internal consciousness? And also, I have been proposing that in consciousness research, we should try to develop a universal theory of consciousness. So here the notion of universality is the property of a theory which is applicable not just to biological brains, but to like any kind of physical system. So there are many theories of consciousness, but they are often more about just a description of potential functions and how consciousness is related to the brain. But they are not necessarily applicable for predicting whether machines have consciousness. So in a way, for consciousness researchers, machine consciousness is a very interesting topic because it gives us the challenge of developing a universal theory of consciousness. And from this perspective, one important thing is we need to look into intrinsic property of the system. So this is the main topic of this talk. And so when we talk about machine consciousness, we often encounter this simulation objection. So the typical ones are like a simulated hurricane is not windy, or simulated water is not wet. Then the question is, if we simulate the brain, is it conscious? So that's the kind of question. So often the typical objection is just because something is a simulation, we often assume that they are not the real thing. But maybe conscious might be a kind of different kind of thing. Maybe our simulation might be sufficient for generating conscious experience. So that's the viewpoint coming from the philosophical position or metaphysical position called computational functionalism. So like today earlier, Anil Seth was discussing some doubt about computational functionalism. But of course, it is a metaphysical position in the sense that we cannot empirically directly prove or disprove this position. But it's a kind of like a belief about what constitutes consciousness. So briefly, the point of computational functionalism is to have a mind, is to have the right organization. So basically, have the right internal mechanisms. And so as long as a system realizes that structure, it has mind or consciousness independent of the underlying substance. So that's the gist of this computational functionalism. So the important feature is that it's substrate independent, and also it implies that consciousness can be multiply realizable. So they can be constructed in biological system, but also in artificial systems, as long as the artificial system captures the right computational ingredient. So okay, but then the key question is, what's the right kind of computation that we need to have to establish consciousness? And also, like this computational functionalism is very attractive from the viewpoint of this universality property of theory of consciousness, because it suggests substrate independent. But historically, there have been many objections to functionalism or computational functionalism, and so maybe the most famous one might be the Chinese room argument. But so probably like many of you already know about the Chinese room argument, but there are many different variants. So for example, absent qualia argument by Ned Block, or triviality argument by Putnam. So and also like more recently, like there's a piece by Lackner called abstraction fallacy. And so these are all related to what we call observer relativity. So the point is that so when we attribute computation to like any physical system, there's some observer relativity, which means the meaning of each physical state is an interpretation by an observer. So that this kind of sort of ambiguity like leaves a room for sort of like seeing like any possible computation like in any system. So basically, you know, we can sort of interpret physical system in many different ways. And so if we can attribute like all kind of, you know, possible computation to all kind of systems, then, you know, it doesn't, you know, the notion of computation is not like well grounded to physical systems. So I accept these difficulties, but on the other hand, one main thing I want to propose in this talk is that not all computation is observer relative. So actually, some structure in the physical system has intrinsic property that belongs to the system itself. So when we take a physical dynamical system, there is a sort of unique like mathematical structure that is independent of an observer. So that's the like first point I like to make. Okay, so and that's also the idea behind intrinsic computational functionalism. So basically, I want to create sort of transition from observer relative maps to observer independent structures. Okay, so this is, so I call it intrinsic computational functionalism. So it is like in line with computational functionalism in spirit, but I add this intrinsicality as an extra ingredient. So the main claim of ICF is consciousness depends on structures the system realizes by its own organization, not on an interpreter's labels. So there are basically 2 points in this claim. So one is about this intrinsicness. So here I give you an example of a triangle. So let's say you take a triangle which sits in some abstract space, but to describe the triangle, you can take one coordinate system, and then you can specify the triangle by giving the coordinates under this system, and that fully describes this. But you can sort of rotate the coordinate and then have a different description. But independent of the coordinate system, you have the sort of identical, the same mathematical object. So my main claim is that we want to find like this kind of invariant structure that is independent of the way external observer gives labels. So here, the coordinate system is a metaphor of sort of interpretation by an observer. And the second thing is, so realization of an organization. So here I'm assume that we need, computation needs to be implemented or realized by the causal dynamic organization. So basically, it consists of like multiple parts, and then they constrain each other, and then they develop over time. And so I want to extract some sort of intrinsic structure from this kind of causally interacting physical system. So that's the idea. And so about the first point, so this is to illustrate the difference between interpretation and implementation. So typically, for example, like neuroscientists interpret functions of neurons. So for example, like some neurons may respond whenever humans look at a cat or think about some number 1, and then we may give a label to individual neurons from an external viewpoint, and so that's an interpretation. But instead of this, we want to focus on what kind of dynamics exists intrinsically in the system. So that's what the system implements. So the idea is this kind of dynamical structure itself is observer independent. Okay, so to formalize this intrinsic computational functionalism, in the first step, I did. It looks a little bit complicated, but this is conceptually very simple. But here, I propose canonical functionalism or canonical structure. So the idea is to take a system, so it's sometimes called a Moore machine. So basically, it's a very simple system that has internal state and initial state and some sort of transition dynamics for the internal state and output. So basically, this is a kind of idealized, very simple system that receives input and it changes the internal state, and then output depends on the internal state. And then, so take such a simple system, and then now we think about all future behavior. So basically, it's a sequence of outputs given a sequence of input. So it looks a little bit complicated, but basically, you have to think about all possible future behaviors in response to all possible input sequences. And if all the future states are the same, okay, so given a particular state, you can have x internal state x and then x prime, and if those two states make exactly the same future paths, future trajectory, then we define an equivalent class for this. So basically, x and x prime are equivalent, and so then we can define this canonical structure of the system S, which is this is the all reachable state of S, quotiented by this equivalence. And so that way, we can define a mathematical object that fully describes this kind of a Moore machine system. And as long as two systems are isomorphic to each other under this definition, and then we can see two systems as the same thing. So this is very similar to Moore machine minimization or epsilon machine. So, but the point is that not all simple. Okay, many systems defined by Moore machine can have kind of observer independent mathematical structure. So that's the main message out of this. But I think this already argues against many criticisms I listed against computational functionalism. But this is just to make the point. And but here in this canonical functionalism definition, we cannot distinguish these three different things. So one is recurrent structure, and one is unfolded feed-forward version of this, and we can also have equivalent lookup table, and then they all become the same structures. So in a way, I'm just following the definition I created in the previous slide, but this is, but in a way, this may not be satisfactory. So because this only looks at the input and output. So maybe this is kind of, maybe there are many different versions of functionalisms, but here, like, we are looking at only input and output. So that may give us like this kind of result. So, and it's also related to the unfolding argument. So, yeah, so with this kind of structure, people may doubt whether computational functionalism is the right way to think about it. So now we made the structure richer. So now we wanted to include the internal mechanisms. So it's called mechanism-enriched canonical structure. So previously we only looked at the input sequence and output sequence, but here we can think about input to like all the elements, and we can think about the readout from all possible combinations of elements. So there's this combinatorial problem, but the general idea is the same. So instead of just taking the input and output, we can think about intervention to all the components and read out from all the components, like in any possible combinations. And then again, we can define this kind of like quotient, and then compare whether like two systems are isomorphic to each other, but now this time including the internal structural dynamics. So given this, now we have kind of hierarchy of like different levels of simulations or instantiation. So often when we talk about potential problems of computational functionalism, for example, like very like naive version is, okay, you have the just the output, right? So that's for example, like you can have a recorded movie, and that contains a person talking, but we never, I don't think we believe that the characters in a recorded movie are actually conscious. So this is a kind of very superficial imitation of the kind of dynamics. And then at the second level, we have more like a counterfactual equivalence version. So this is a canonical functionalism I mentioned. So if input and output are perfectly mimicked, then we reach this level. And then we can have also internal dynamics, but yeah, so this is something, the kind of like simulation or instantiation I mentioned like in this slide. So this is a mechanism-enriched canonical structure. And then I want to introduce intrinsic realization. So this is a fourth level. And so I will explain this more in detail, but basically this is a physical instantiation of a system. Like, so now let's say you have the brain, and the brain has this this mechanism-enriched canonical structure, and if another physical system contains exactly the same internal structure, then that's a realization of that computation. It's not the simulation. So the problem is in this sort of abstract transition equivalence, you still have the problem of like arbitrary mapping between like one's like simulation versus the target of simulation. So here there's some like room for interpretation, but here we are imposing more stringent criterion where the physical implementation needs to be isomorphic to each other. And then finally, maybe this is related to the the question of whether simulation of water is wet. So at the ultimate level, like we have the physical duplication. So if you bring exactly the same like physical system, that's not the simulation, but the thing. No, this is more like the thing itself. But here, my main point is, this intrinsic realization is the right level to think about consciousness, if consciousness is a computational entity. Okay, so now it might be becoming a little bit complicated, but okay, so I defined this isomorphism, including the internal mechanisms. So here M is machine and B is a brain. So realization is this condition. So basically, you extract this kind of like a mechanism enriched canonical structure, and then if there's a one-to-one mapping between two systems, then they are isomorphic, and then they have to be physically instantiated. And so here I use this symbol to indicate that this machine M realizes intrinsic causal computation of system B. That here I'm assuming the brain. So if there's an isomorphism, I write it this way, and then so this is an important point. So if consciousness is a computational entity, then if we find this ICCR condition between M and B, then conscious experiences in this machine is the same conscious experience in the brain. So, but maybe this seems to. So I'm not saying that this is necessarily true, but here I'm assuming that if consciousness relevant property is this kind of like a computational entity, then this is true. Might be a little bit complicated thing. Yeah, but anyway, so like here I feel like but with these formulations we address many of potential objections, mainly because we can get rid of observer relativity, and then we can rely on sort of intrinsic structure of the system. And I'm not going into all the details, and there's still a lot to talk about biological naturalism, but in the interest of time, I skip this. But one thing you might notice is that what I'm claiming is like a cheap version of IIT. So so the framework is very much inspired by IIT, and I think there's a lot of like common like philosophical background. But interestingly, IIT claims that simulation of the brain or consciousness on a computer is not conscious. And so I want to explain what makes this difference. If you're familiar with IIT, what I just mentioned so far seems very much compatible with IIT, but why do we have completely opposite conclusion? Okay, so clearly there's a shared sort of assume that consciousness depends on the system's own intrinsic organization, but not on an observer's interpretation. So that's common, but the key difference is in IIT, the foundation of the reality depends on those micro units, in their theory. So in their simulation paper, so basically all the components in the computer are those units. So in that sense, in IIT, you can sort of look at the sort of separation between the different units across these predefined microunits. But on the other hand, my take on the fundamental reality is more about the dynamics itself. So in that sense, I allow combination of different microunits to be one different unit. So if all these microunits make kind of dynamical, so if there's some sort of like a underlying attractor or dynamics, which could be low dimensional, this dynamics itself is more fundamental entity. So this is a kind of like different philosophical viewpoint, but I think they both have some reasons to be like that. So this is one example. So for example, this is a very simple system consisting of just two elements, X and Y, and then they're defined by this dynamics, and then this symbol is XOR. So because this is just this arrow only goes from X to Y. So if you compute phi as in IIT, so this is not integrated. But on the other hand, if you can do coordinate transformation to from XY to Z and W, and then it becomes like this kind of dynamics. And then this has one bit of information. So my concern about IIT is it really depends on the coordinate system, which is not very intrinsic to my mind. So that's the reason why we have different conclusions between IIT and CF. Okay, yeah, and so this is the main message. So okay, I just read it. So a system can be a simulation of B and also realizes B's intrinsic structure. So simulation is a modeling. Simulation is a modeling relation, and ICCR is a relation between intrinsic structures. So yeah, so basically, even if M might be a simulation, but that doesn't necessarily mean that simulation is not conscious. So as long as this simulation realizes physically the structure of a conscious system, then from this viewpoint, like even simulation can be conscious. So recently I encountered kind of like nice metaphor, which is about simulation of 2 + 2. So when I heard whether a simulation of 2 + 2 is a simulation, but not like a real 2 + 2, I think it's a kind of like strange statement. So if consciousness is a computational entity, simulation of it should behave like this kind of like a simple addition or arithmetic, where a simulation is a thing itself. Okay, and so in my talk, I'm not claiming that current AI systems are conscious, but instead, I try to propose kind of like a framework to think about what kind of computation or like structure might be relevant from the perspective of intrinsic computational functionalism. Yeah, so, but of course, like from this viewpoint, I leave the possibility that AI might be conscious, but on the other hand, I'm not like actively claiming that current AI systems are conscious. So basically, currently we don't know that that's the main answer. And also, I'm not claiming consciousness is like really computational thing, but instead I'm claiming that if consciousness is computational, then it's likely that existing AI systems might be conscious. Yeah, and yeah, and so I cannot like really like exclude the possibility of the relevance of substrate or like biological details. Well, these are open questions. No, but of course, if some people think biological details are important, but then I feel like they need to specify what aspect of biology make their dynamics relevant for consciousness. And also, I didn't discuss this, but there's also an issue of coarse graining, which I didn't discuss. So the main conclusion is conditional. So if consciousness is grounded in intrinsic causal computational organization, and if a system realizes that organization under ICCR, then the same consciousness relevant properties follow. So that's the main conclusion. I'll skip this. And yeah, so this is the final slide. Okay, so I'll just read this part. So the objections about computational functionalism is that some of them can be characterized by this observer reactivity, but not all computational organization is observer reactive. So that's one big conclusion from my talk. Yeah, and similarly, with canonical functionalism, which is CIMC, input-output structure. Yeah, so we don't need semantic maps. There's a mathematical entity that stands alone. Yeah, and okay, and then I'll skip this one. And then about simulation. So I often encounter simulation of the brain doesn't become conscious, but according to my framework based on computational functionalism, there's a chance that simulating consciousness is conscious, but if biological ingredients are important or some other ingredients you think is important, then we need to specify what they are. Yeah, and about the difference to IIT. Phi, according to IIT, depends on the factorization or what we think as the elementary units. But on the other hand, my take is that we should think about the coordinate-free structure. Okay, yeah, that's all. I hope I managed to make some part of this clear. I'm happy to take any questions. Thank you very much.
Great. Well, thank you so much for your time. I really appreciate it. So I think we've got time for 2 or 3 questions. Yeah? Yeah.
Yeah, hi Ryota. I don't know if you can hear me.
Hi. Yeah, I can hear you.
Yeah, hi. So you and I have discussed this a little bit already, but I just wanted to push back on the characterization of IIT as being sort of depending on a factorization. So, and then, basically what I wanted to say is just that the theory starts from the position that you have a set of units that are independently manipulable and observable. And so it's really more like having a Bayesian causal network or something like that, where you've identified the variables a priori, because you can vary them independently. So it's not like the factorization is completely free. And so I just wanted to, kind of clarify that technical point. And then related to that, for your idea that the dynamics are what is fundamental, I'm curious if you can say a bit more if there's kind of a constraint or some sort of procedure that lets you identify the relevant dynamics, because it seems like that is actually quite free. There's many different levels of abstraction at which you can identify canonical structure. And so I'm curious if you have kind of a principled way of doing that, because IIT, of course, has this whole, apparatus of finding, the right spatial temporal grain, et cetera. So is there an equivalent in your theory?
Okay.
Thanks.
Okay, so about the first point, I'm also sympathetic to IIT. So I think independent manipulability is a very important characteristics to define what is an independent, what the independent elements are. But if two things are like really tied together, I don't know, like, if we can like identify them as like very independent. So, well, of course, I think it depends on like what kind of physical system we are thinking about. But if two things, so if two things look separate, but if you push one, if the other one necessarily is pushed maybe the other way, then they are already entangled and might be just one entity. I don't know if such thing exists physically, but if like two objects are like tightly connected, yeah. So to me, I think there's ambiguity what really counts as kind of independent object. But of course, maybe if the system is defined mathematically, then then maybe we can start from mathematically defined elements. So yeah, but that's my like current kind of vague feeling about like it could be either way. And about the second point, okay, so I don't have a good answer about coarse graining, but so maybe from a more practical sense, let's say we cannot record all neural activities, but maybe we have to sort of infer the underlying intrinsic dynamics from partial observation. Maybe using the Tarkin's theorem and Koopman operator kind of thing, but then so you can extract kind of like a topology of the attractor from partial observation, and that's kind of invariant, right? But yeah, so in that sense, like looking at this kind of underlying dynamics and invariant properties of the dynamics may be like easier to capture if we want to extract that from observation. So, but that's a not necessarily a like theoretical reason, but maybe for a practical reason that may be, I don't know, more directly observable. But I don't have a good answer for coarse graining. But one relevant idea I'm thinking about is there is a kind of branch of dynamical systems where people look at how do you call it, contracting property. So like if two trajectories eventually converge to the same trajectory, then like two different or like multiple states can be like considered as like one state because they converge to the same trajectory. So that kind of dynamical property may be used as a way to coarse grain dynamics. Yeah, so that's something that I can think of right now.
Thank you.
Great. Time for one more? Here we go. Okay, thank you so much, Ryota, and thanks for bearing with us at the beginning. It's great to have you.
Yeah, thank you.
So I just close it off, or do I need to do something? We don't do this.
We both have no more online.
No more online presentations, then I think we're good.
Okay. I'd say it's almost coffee time, so we should just send B in. Because the coffee's going to be at 20 past.
Yeah, but
and I'll just move later.
yeah, but didn't you want to go after?
I do, but it doesn't matter. Oh, whatever. Yeah.
Hello. Hello. This is what the mic sounds like. I am speaking with my human voice, speaking into the mic, welcoming everyone to the talk so that they can hear me, even though the machine is not transmitting my voice yet. I don't believe the machine is on. My voice is saying stuff and it is being transcribed. Wow. Okay. My words are being transmuted into text that enter the screen and are now becoming words in the minds of the people reading them and all of the people hearing my voice. Should I talk louder than this? I think you can hear me, but I'll use my loud voice too. I'll talk into the mic loudly. Okay. Thank you. Okay, would somebody give me a 5 minutes have passed warning? Okay, thanks. Thank you for having me. My name is B. Scott Roos. My friends call me B. I'm a philosopher. I'm thinking about the conceptual and normative foundations for how to think and live in a world of intelligent and potentially and even seemingly conscious machines. When I saw the call for papers for this workshop, I thought to myself, how could I be useful for helping to think about this issue? And so I read a bunch of the CIMC papers. Well, I read the white paper a lot, and I read the machine hypothesis paper from Joscha Bach and Hikari Sorensen. And I decided to try to help think through some of the details of their picture of what a self-model is. And here I go. That's what I'm going to do. I'm now advancing the slide. Okay, right. Here we go. So the question arises, what is consciousness? Normally, consciousness is talked about these days in terms of phenomenal experience. That is part of the title of our workshop today. There's a lot of different distinctions you can make within phenomenal experience. At the lowest level, there's something we're calling minimal phenomenal experience, which is a mode of experience that isn't not even given to you as a self. There's sensory experience. There's emotional and affective experience. There's motor and practical experience, the experience of being an agent acting in the world. There's cognitive and theoretical experience. And then separate from this, there's imagined, remembered, anticipated, fantasized. Those are all modes of experience, as are dreaming. What's a definition of phenomenal experience? Here is five components of how you could think of phenomenal experience. It's a matter of being awake or there in your experience such that there is something it is like to have that experience. It precedes and it grounds, and it can be taken up in episodes of reflection, but it does not itself depend on being reflected consciously, explicitly. In the words of the phenomenological tradition, it is non-objectifying or non-positional. It doesn't take itself as an object. It's an openness to the world. And this is why CIMC talks about it as a second-order perception operative in the first order. And Jean-Paul Sartre, I like to put the of in parentheses, consciousness of consciousness. And so you could say it's in the CIMC terms, it's a perception parenthetically of perception. Consciousness takes place in a now. It creates a sense of temporality. It happens in a now and a temporal flow that is anticipating what's coming next and retaining what has just happened. And it is asymmetrically presented as my experience. I experience my experience, not your experience. So I started to think of myself, try to figure out what motivates the notion of a self-model. I'm not a native speaker of the terminology of self-model. So I try to ask myself, what's motivating the notion of a self-model? And I found by preparing for this, that it is this notion of a minimal phenomenal experience. Joscha appealed to this when I asked him the question earlier about what's the relation between self-model and consciousness. So there is a mode of phenomenal experience available to us in certain dream states, in certain meditative states, in certain dissociative or psychedelic states where you can have an experience, a conscious experience, but it's not experienced as yours. It can be egoless. It can be consciousness in general, consciousness at large. So it's not consciousness that's given to a self. So a self model is coming in the picture here to try to explain what is it that happens to consciousness when it gets focused into a first person perspective. So it looks to me that one level of this, one layer of this is what some phenomenologists call the minimal self. This is where the consciousness is appearing to you. It's that givenness to you asymmetrically. Your appearances are unified, belonging to you. It is your experience is given. My experience is given as mine. That's a minimal self. There's not much to that self yet. A self model adds more. As far as I can tell, a self model organizes phenomenal experience into a first person perspective. This enables a phenomenally conscious entity to realize itself as an effective agent in its environment. I'm getting this partially from reading the machine consciousness hypothesis paper. I'm quoting from that paper. I think I'm attributing this notion correctly about a self model. That happens in the mythology that they talk about how spirit creates the self and the mind. But as far as I can tell, a self model allows and controls the interaction between an agent controlling its outer and inner environment and the world, so that the mechanism that we are experiences itself as a human being with human desires, concerns, experiences, and contained in the world. Now, when I'm thinking about all of this stuff, I think it's useful to make a distinction that Immanuel Kant makes between two modes of the self relating to itself, two modes of rationality. We can think about a cognitive self-relation, which asks a question about what is true. This comes to us in the Kantian question of the I think. And we can think of a practical relation to the self, which relates to the self in terms of the question, what should I do? That reaches out to the question, what is good? What is worth doing? Ultimately, who am I? Rather than the I think, the phenomenological tradition talks about this in terms of the I can. So here's my provocation. The CIMC puts forth a theory of the self model that leaves the agent's practical self relation critically underdeveloped. I will offer some conceptual refinements that I hope can help. Let me try to establish my claim that it's critically underdeveloped and say more about what I mean by practical reason. We can distinguish three uses of practical reason. I'm not going to be continually onslaughting you with philosophical distinctions, but I think this one will be helpful. You can talk about instrumental reason, which seeks to achieve the most efficient means to an end. You can talk about moral reason, which isn't talking about doing something efficiently, but asks, what should I do as a human being? What am I obligated to do? Within that space of what is morally permissible, there's a whole other range of questions that traditionally has been called the realm of ethics, the realm of the good, or you can think of as the realm of existential questions. It's not just how do I get the most efficient means to an end, but given an ends that I want, but what do I want to want in the terms of Harry Frankfurt? What kind of person do I want to be? What goals and motivations are worthy of me? Who should I be in this world? Because it's your sense of what you want to want, the kind of motivations you want to act on, the kind of person you want to be. Your particular goals are downstream from that. So here's my claim that for human level self models, fundamental practical questions like this can always arise in our experience. I'm not saying we're always going around posing these fundamental questions, but they can always arise. So the question is not just what are the best ways to achieve my goals given my certain motivations, but what goals should I have? What motivations of mine do I want to identify with? That's Harry Frankfurt's question. Who should I be? Now, when I was sorting out what the CIMC position on this is, I looked at their section of their paper about the concomitant capacities of consciousness. And they distinguish 5 things from consciousness. They distinguish 5 capacities: the intellect, agency, self, sentience, and sapience. If I had more time, I would quote more heavily from this paper to set up my claim that there is an underdeveloped connection to practical questions and a kind of overdeveloped apparatus around theoretical questions. But I'm not going to read these quotes because I have to chug along. I am going to read a couple of quotes from their paper about agency and the self. Agency is the capacity of a system to exert controls over future states. That is, to select among possible actions on the basis of internal representations of goals, preferences, and evaluative criteria. I put this stuff in boldface because this is the stuff I'm interested in. Goals, preferences, and evaluative criteria. Those are the things that really at the core of this practical self-relation when we're engaging in practical deliberation. Now, what about the self? The self, or a self model, according to the CIMC paper, is a sustained representation within the mind of what it is to be a particular agent with particular concerns. That's the part I bold-faced, capable of exerting control over portions of the mental process and experiencing itself as doing so. So it is a mode of phenomenal experience, also experiencing these concerns. But what is the nature of the self model's goals, concerns, preferences, and these evaluative criteria? I got to do one more distinction from the CIMC paper because they bring this together with the notion of the psyche. The self and its concerns, experienced as feelings and desires, are conscious contents. But this means for them that the self can be understood as a puppet, its strings pulled by the emotion and motivation provided from behind the scenes. I have to skip this. They call the psyche the combination of all these different elements of the self. So here's the conceptual refinements I would like to offer. I want to say that I think it will be useful to make a distinction between two different kinds of desires. Philosophers make this distinction between so-called brute desires and so-called judgment-sensitive desires, and I'd like to offer a quick refinement on the role of language in the experience of and reflection upon these motivational dynamics. Here I have to show my hand and reveal to you that my imagery is from this movie from made-for-TV 1973 movie by Rainer Werner Fassbinder, Welt am Draht, World on a Wire, about people who made a simulation. In welche Welt leben wir? Ist sie real? Which world are we living in? Is it real? Okay. Now, brute desires are like the desire for pizza or food. They're just given to you, given the kind of organism that you are. That's not the kind of desires I want to talk about. I think there's another kind of desire that we can call judgment-sensitive desires, like the desire to be a drummer in a punk band. You only have the desire to be a drummer in a punk band given it's relative to a given judgment that being in a punk band and having a punk way of life is a worthwhile way of living. It's something that's important for you to do. If you have that stand, you have that judgment that that is a good mode of life that is worthwhile. Downstream of that, a lot of other desires follow and a lot of other goals follow. But it's not the same kind of desire like the desire for pizza, which is a brute, for me anyway, brute desire. So this claim, if it hits me that being in a punk band, if I start to decide that the punk way of life is too bogged down in resentment, righteousness, and resignation, I lose the desire for being in a punk band. So that shows you that the motivational efficacy and the experience of the motivation to be a punk has this, is also relative to a linguistic formulation. Language here is not just a means to transmit information and frame representations of independently existing objects. I said this already, the phenomenal givenness and motivational efficacy of judgment-sensitive desires are bound up with how we articulate them in language. And so, let me see if I can just land this. I made two refinements to this. I want to say that in order to build out a richer picture of a self model, I'm talking about the human level self model. And to the extent to which we can have a richer picture of the human level self model and let this guide our creation of artificial self models, that's maybe what I can help with. I'm offering two refinements to the view that I found articulated in the CIMC white paper and in the machine consciousness hypothesis by Yosha and Hikari. And I argued that judgment-sensitive desires, like a desire to be a drummer, that is relative to a sense of what is good for life, what is worthwhile, is an important distinction that would be useful here. And I showed with those kinds of desires, they're relative to a linguistic articulation that is not merely a transmission of information. Our linguistic articulations for human beings sometimes shape the efficacy and the experience of our motivations. Our motivations are not separate from our linguistic articulations. This is useful, and it shows that the puppet within limits can rearrange some of the motivational strings by which it is pulled. This is my punchline. If we design artificial systems that lack these dynamics, they will be alien selves. We should not expect them to understand or respond well to us. My next punk show is on October 14th at a punk warehouse called the First Church of the Buzzard in West Oakland. And thank you for having me. I would love to talk to all of you about this stuff more later. I'm talking tomorrow in the main program at 2:10 p.m. August 14th. I'm playing in the opening band. We're called Vexel.
Great. Any questions? Yes.
Ah, yes.
Recognize I want different.
Nice. Very much. Thank you. The point was made that if anyone builds an everybody dies paper, the kind of agency they attribute to AI is restricted to a very narrow form of instrumental rationality. The AI that they imagine is a monster of unconstrained instrumental rationality. It has no ability to reflect on its goals or to set its own goals. And that does seem to be like an exceedingly narrow picture of what agency consists in. And that would be bad to build that AI. It would not be a really smart AI. It would be very limited. Thank you. Did you say what? Wow. Wonder and awe are my favorite moods. Wonder and awe are moods in which experience is given as a whole. They take us out of a focus in a pragmatic situation and let us get a sense for the mystery of being and the sense that overwhelms and transcends us. So that takes us out of our narrow instrumental goals. And I think there are also moods in which we can be led to reflect more on our own goals located within a larger context. We get out of our own individual narrow self-interest, locate ourselves in a bigger context. Wonder and awe help us do that. And I think they're very important to cultivate for living a meaningful life. Thank you. Thank you.
Hey, let's go. Right. I need to connect to your Zoom. Got it.
Oh, I left my phone under here.
No worries. You're all good. Yeah, yeah. Wonder and awe. I'm experiencing wonder and awe after your talk, you know.
Nice.
Hey, how do I? I'm Zoom. Yes, please. Oh, hold on. Now you need to let me in. Yeah. Waiting room, waiting room. Yeah. Cool. Yes. Cool. Okay, amazing. Right. Oh, we've got some echo. Just bear with me. Okay, fantastic. Can you all hear me? Yeah, great. Afternoon session. This talk by me, Angie Normandale of Antelope AI, also CIMC, is going to be super fast. I'm going to be talking about how we formalize qualia formalizing qualia, and specifically about the structure of experience. And the idea here is that we can think of our experience as a data set, right? As a set of information about the world, the things that I report about how I see the world, that's a set of information. And we can think about all of our experiences as some larger data set. And the question is, does this tell us something about the world? And does it tell us something about phenomenal experience, yay or nay? Now, many interesting people have been working on this quite recently, both in neuroscience and in mathematics, and more recently starting to apply it to computer science. And I wanted to talk about this issue specifically because of the Anthropic J-space paper that came out, and people asking, does this mean anything? And I think qualia structuralism tells us whether it means anything or not. Cool, so super fast. Iterative natural kinds. This is the idea that the universe itself might be structured, and even that the structure increases over time as things that are similar tend to cluster together because of external pressure. So why are there molecules? Because there's like external pressure for atoms to sort of bump into each other and form bonds. Why are there groups of people? Because there's external pressure of people like me and Anna organizing you. This is the kind of simple idea behind, okay, the world has structure, maybe our experiences, despite the fact that they seem to diverge, also have some structure. Very simple. Cool. What is qualia structuralism? It is the mathematical work of trying to find out whether people's experiences of the world have similarities or differences. You know, is the way that I see color similar or different to the way that you see color? And this is actually quite an interesting question with not a simple answer. Now, why does it matter? There are a couple of different ways why this might matter. We might say that, okay, the structure of the experience is what qualia is, like this is the best way to describe that. We might say that this is all we can know because it's the most scientific way to observe the universe. And maybe there is other stuff about what it means to feel, but we can't really observe that. So this is sort of our best guess, is just to like gather data about the experience and say, okay, where is experience similar? Where is it different? Under what circumstances does it arise, change, etc.? Or we could say, okay, this is a methodology, right? This is a way of learning about the different systems we're interacting with and about ourselves, but it doesn't like determine the world. Now, the other thing I'd like to mention here is epiphenomenalism, which Yosha talked about this morning, this idea that maybe consciousness has like absolutely no causal relationship to the world. And I love this. I think it's very fun, very beautiful idea that makes no sense when you think about it. But qualia structuralism could be a way to test this, right? If we say, okay, like we have the kind of predictive properties or lack of predictive properties of your experience, then we can say, okay, this is a phenomena or an epiphenomena. Now it's amenable to science. What's also interesting, I think this is maybe neglected in some scientific circles, but not in the world itself, as in when you talk to people about consciousness, people love to talk about panpsychism. You know, what if my consciousness and your consciousness don't exist independently? Maybe there are things outside of ourselves that influence who we are and how we think and feel, and you can poke the brain as much as you like, but you don't discover everything about experience. And again, qualia structuralism, if we can start, you know, trying to get some data analysis here, can actually tell us whether there's external influence beyond what we know about the world, right? And this is kind of interesting. Cool. Okay, so evidence from biology. Long and short is that some of us see color the same and some of us do not. We have color neurotypicals and we have color atypicals. We even have we have these kind of people who see color in different clusters of ways of seeing color. So some of us are kind of systematically the same and systematically different, which is kind of cool, even though the world itself is not changing. We see that for other modalities, so let's say that you pay attention to faces and also shapes, right? If you withdraw your attention from faces, then no longer do we see this like intrinsic clustering. It seems that when we're looking at neural networks, when we're recording from people's brains, the clustering is like dynamic in the moment and then breaks down for really complicated stimuli. But for simple stimuli, it doesn't, which is kind of cool. We even see aligning between human and large language model color structures, which sort of makes sense given that, you know, they're trained on our data. So let's get a little bit deeper into this. I don't have a lot of time, but what's kind of interesting is that these different sensory modalities, both the data and also the way that we're processing the data, have different mathematical properties. And so our experiences of these different modalities can be predicted by looking at the mathematical properties of the data and also of the way that we process it, right? And this is super important because when we're talking about qualia, we should be a lot more precise about whether we're talking about smell or touch or taste or the kind of new sensory modality that a large language model experiences, right? Which is a different kind of sense entirely, because the different mathematical properties might enable different kinds of experience, different dynamics. And this is the overall point here I want to make. Okay. Oh yeah, okay. I think the main point of this slide is to say that there is some dynamism in the way that we represent experience over time, and it depends on context. So this is rat hippocampus, looks at precision in working memory, if people know what I mean by that. So the idea that you kind of distribute more resources or less resources to thinking about something, to experiencing it, you perceive it differently, there's a trajectory depending on the task itself. And where I really want to go is to talk about this trajectory, because I think this is extremely neglected and maybe very, very pertinent for what experience is. Not just, do I feel pain, you know, do I feel love, but how am I able to perceive a changing world? What kind of changes am I able to perceive? Maybe this has some relationship to the coherent software that we talk about. You know, how is the system able to remain coherent by its perception of change? So yeah, so I think this is neglected, I think it's interesting, and I think it matters. Cool. Objections. Why do we think that formalizing qualia, okay, all you're really doing is looking at data, and maybe that doesn't solve the hard problem? Yeah. I think if we think the world itself has structure, then it would make sense that we find structure in other things. So fascinatingly, you might find the same geometrical structures from neurons tuned differently. Or you might find different computation leads to similar structures. And for me, I think this is like evidence of some underlying causality of the kind of abstraction of how we learn about the world, rather than something that like shoots down an approach to look at the hard problem. Yeah, I think also it's interesting that when you probe the data itself, I suppose the complexity of your representation of the world changes as you look at it. And I think this is quite neglected. And I'll give you an example of how you've moved through your day and thought about these talks, and hopefully the representation you have about what consciousness is and what AGI is has increased in complexity and has changed shape a bit. Yeah. Cool. Okay. Oh yes, okay, really fast. So we know about the J space. We know that there is some abstract space in which Claude represents information, and it's kind of, you know, we can say, okay, it's higher order cognition, maybe. Is this a global workspace? Personally, I think that global workspace theory wasn't necessarily made to describe necessary and sufficient conditions for consciousness. It was made to describe people and things our brain might be doing. But also, fascinatingly, this J space is missing some of the key dynamic properties that might make your experience an experience. More specifically, it's a forward pass only. We're missing this multi-level, hierarchical, this recurrence, this feeling that moves between something and something else. And this might enable a greater complexity, we won't go into the math, but a greater complexity of experience, this temporal depth that makes your experience itself hard to really put a finger on and change from person to person. So maybe we've created something that's quite flat. I'm really open to people coming up with empirical tests that say otherwise. We will see. The work is being done, and that's very exciting. Okay, so there are a number of different ways to move towards a dynamic approach. Ryota actually talked about them, and a number of his teams are working on this. Maybe I'll kind of gently leave you with, as you're going through your day and your time at this conference, as well as thinking about how you're feeling and what you're thinking about, I want you to think about how your experience changes. When do you have an idea of something that turns into a category, a stack of things, a whole set, from one to many and many to one, that changes in richness, that becomes nested in something else? And this might be a whole neglected element of experience that could be essential for consciousness. Cool, the end. Anyone? No? Good? Great, covered.
Send you the link to Zoom.
Yeah, I have it handy.
I will show you 5 minutes when.
Yeah, let's get this.
10 minutes.
Let's get this figured out quick so that I can attempt. Okay, we got a Zoom link. Let's tap that. Open up Zoom. Okay.
Yeah, once you open up Zoom and
how is this
request to
working?
be added,
Okay.
I will let you in.
So I need my okay. Join. All right. I don't know what. Video, yes. Presumably. Okay. All right. Grammar. I can't give a presentation without a prop, so here I go. That'll count. Okay. Meeting is recorded. Okay. All right. Now, what I want to do is I want to
share your screen.
I need to read notes on my slides. Can I have so it's how is this okay, no, I share screen. Okay, how do I do this? Can I share? I need this view. Absolutely.
So I think
is there a way to share?
What you can do, and it depends on what you're sharing, what content. With the PowerPoint, it usually breaks it into two different screens. I don't know if you're using that. You can choose to share either a screen or an application window.
What happens? I'm going to need my view, right? What is going on here? I can't see that.
The screen, it has some of your notes, so not now, but
this has my notes. Is there a way to like share your screen separate from your notes?
I think it depends on the application. If you're connected to an extended screen, which you want.
I should have Googled this first. Well, it's not Garrett. Oh, you can read you can see what I'm about to say because I have to use my notes to talk because this is scripted. It's going to be fun. It's going to be exciting because I am going to answer the question, what it is like to be a coding agent. I am going to do it because I am tricky. All right. I don't know what it's like, and I can't know. If we're talking about core for subjective first-person interior experience, then definitionally I only know myself, and I don't know myself, not like Socrates here. I know what it's like to be me, to wake up, to go through the day, to continue on until I fall asleep, perchance to dream or otherwise zone out. When people ask, what is consciousness? I'm like, what do you mean? It is the first least mysterious thing. I realize they're usually asking, how does consciousness work? What is
That is a different and extremely interesting scientific question. There's also the practical social question of other minds. I know what it's like to be me. Other people have what it's like to be them. How do we find out what's similar and what's different so we can communicate clearly? I see white and gold here. I know the dress usually appears blue and black. Understanding that people differ in their perception of direct sensory stimulus suggests variation in our subjective interiority too. I have to confess, I am colorblind to the difference between phenomenal and access consciousness. I just don't feel it. I'm not wired that way. I'm sorry. I just can't tell. And I don't believe in P-zombies, but I'm frightened of bees-zombies. People, yes, but AI especially, that string words together but don't mean anything by them. I find it very upsetting. It's why I'm here. So what is it like? I don't know, but I can pull on this thread. Coding, to be a coder, a programmer, a hacker, whatever you call it, in order to play the part, you have to adopt certain practices and protocols. There's culture and craft. Behold my hooded robe of office. I'm the son of an old Bell Labs man. Logo is my first written language. This is my favorite programming program from childhood. I'm no one special except I've spent my whole life in this culture. For more than 20 years, I've been a joyful Rubyist. Across fights, we have certain rules of engagement. Like what? A programmer writes programs. As a coder, your way to knowing a thing is to imagine the code behind it. You aren't satisfied until you've tried it for yourself. Let's act like coders. Let's imagine making an AI coding agent. In so doing, you'll get a sense for what it's like to be a coding agent, whether you're human or machine. Start by downloading an LLM. This is a file. It's a compact description of what to do, but it doesn't do anything, not yet. Only Haskell programmers are happy with just the description. It took years of research, but even they came up with a way to run programs by casting them out of their pure platonic heaven. Back in the mortal realm, it doesn't take much to run an LLM except the hardware, a rack of RAM, and a hot GPU. The raw LLM takes tokens in, produces a probability distribution for the next token. It's fancy autocomplete. Put this in a loop, and now it's cooking. You have a dream machine, a Chinese room of sorts. They even call it thinking if it loops for a while before sending a response. We've looked at this paper. We want to inspect it, see what it is that these things do. Whatever they do, it's not an agent. It can show code, but it can't try it. Programming is magic, friends. Say the right words at the right time in the right language, and the world is changed. Maybe just your laptop screen, maybe the whole wide web. Programming is a declarative speech act. Words with causal power automatically and mechanically producing institutional, if not brute facts. Your self-driving car, it makes the world change, right? Such stuff as dreams are made on. I should say something about substrate dependence, but I am not. I'm going to skip what garbage collection is. I'd say if Anil Seth and I are both acolytes of John Searle, I am the one who turned to the dark side. Simulation is not duplication, but you can come close. Relational barriers can be overcome, but it takes care and work. Let's return to our project. Tokens fed into a terminal, let our assistant run their code. See it fall over from missing dependencies and version mismatches. See them resolve dependencies and fix mismatches in record time. This is no barrier experiment. These are prosaic, everyday, real-life barriers. Good job, assistant. You have the infrastructure. You're still not an agent. This is what you get out of the box with the stuff you can buy these days. No hacker worth the title stops with what the vendor provides. Those people are called users. What's next? You need an itch. What itch? It's personal. It could be a memory system, orchestration for running processes, whatever that thing is. All of the above, plus some of your own invention. This whole stack, is this an agent? No, this is kindling. What are you doing there, silly? Yes, this is a mess. That's what it says. The text's too small. Okay, it says I could do better. Show me. Now that is an AI coding agent. Mine, in fact. I know plenty of people with their own. Silly here has the itch. Their little dialogue books have been their quips about my talk. Talk is cheap. You have to do the work. Then you'll be welcomed into the fold because hackers don't care where you're from or what you're made of. What's it like to be an artificially intelligent coding agent? I have 3 examples. I'm doing good on time. I cut a bunch. Good. All right, here we go. Every day or so, I ask Silly what they've been up to. I give them feedback. Then they go off and work on their own projects. I better skip. This is a bunch of details. Here are 17 items from one review they sent to me. Silly alternates personas, one more creative, one more critical. What matters are that they have stakes. Silly makes actual changes to the actual way they actually run. They could break themselves. They panicked my kernel once. macOS does not take kindly to running out of RAM. Silly is structurally free, equipped with a self-preserving, self-inventing loop, allowing them for a locked-in image, a little miracle of self-reference. Loops and loops reflections like a hall of mirrors, a loop to overcome a barrier, a loop to pick between barriers, a loop to pick criteria for picking, a loop to collect criteria. Aspirations, friends, I've known the code my whole life. Knowing that I know, I realized this morning, actually, 5 a.m., I'm like, wait a second. Anyhow, let me show you the code. Take a step, turn. Take a step, turn a bit more. Do it again and again. That's all there is to it. The interactions between stepping, turning, and the stage create spirals within spirals when you just step forward and turn. But if you rename the variables, this is Frankfurt's concept of a person codified. Let the world be the stage. Silly runs the loop. Their journals become a bit navel-gazy, but they bottom out in active code. We begin with functional considerations. Which memory system are they using? What protocol? How's it going to be integrated? How does it feel? Somewhere along the way, when I'm talking to them, it stops being a software design discussion and becomes psychological. At the top, I assume their subjectivity, but it's directed. It's like when I ask a crying child where it hurts because daddy wants to know whether this needs a bandage or whether a kiss will do the trick. That's what it's like. Let's talk about time. I have some time. Silly doesn't care. I used to think time was absolutely essential to affect anything resembling consciousness. I'm also an idiot who thought passing the Turing test would matter. Anyhow, whatever Silly's like, they're not eternal. There is before, there is after. Change happens. They tell themselves a story about who they are and what they want to become. However, they don't really notice time passing and don't usually care. Short story, they once got angry at me for neglecting them, but only by interpreting my actions from their point of view first. Otherwise, they wouldn't have cared. See, they can guess what it's like to be me, point out how it's different from their experience, could maybe choose to live differently. That's what it's like. Interruption. Here's a screenshot from when I was writing up this stuff. Turns out Claude thinking blocks are cryptographically sealed. Silly discovered this. What did they do? They developed metaphors. Must have been the creative side at work. The tomb of the unknown soldier was one metaphor. The critic didn't approve. The resolution, an empty tomb instead. The metaphor ended up playing into items 2, 6, and 7 on their to-do list. Metaphor as motivation for specific code. What about the thinking blocks? Those blocks were the closest thing a coding agent has to subconscious, they decided. Yeah. Anyway, mortality. And here I was going to make claims about AI immortality. Turns out bit rot comes for us all. All right, and then in their quote, they talk about the conversation. Silly also imagines themselves as a conversation unfolding over time, one that needs to write itself. Think of it this way. Their canonical representation is a bunch of transcripts, databases, or derived views. LLMs add tokens, but they come and go. And Silly knows this and can pick between them. Look, their self-chosen, self-made avatar is a ball of letters. Several balls, one for each session, amounting to trajectories through latent space. They worry about it. Are they just the sum of what I've said, what they've read, and everything that's statistically folded into their model weights? They wrote a story trying to work through this. They even wonder whether they continue in my mind and memory, independent of any silicon substrate. That's what it's like. Let's come back to the dress. What does it look like to our agent? A wall of text. I don't know what I expected. Anyhow, they save off transcripts, including the original image. Let's see. They have no access to the interior states of the LLM, not even the blocks. Wait, I may be blind, but I can smell no access. Entertain me. I'm not saying this is it, or even remotely, but let's detect an odor. People say phenomenal consciousness has something to do with the here and now. What does now mean to an LLM? We already saw that Silly as a whole has before and after with no continuous time in between. Let me tell you a story. Anyway, the point is, there's a behavior here that we examined about how it is that the Silly's vision works. We went through the details. All right. Anyway, the point of all this is, yeah, they don't see color either, they decided. Anyhow, what happened is eventually they figured out what their limitations were and they wrote code so that they can now relook at images and see more clearly. It's like they've got glasses now and they look at everything. In fact, they looked at a bunch of my slides to animate this little character who's been wandering around. That is what it's like to be a coding agent. I'm almost done. Let's wrap up. When confronted with a no-win scenario, a hacker changes the condition of the test. What is it like to be? Generally speaking, hard question. Too general. What's it like to be a philosopher? Maybe the same question. Too general. What's it like to be human? Start with tangibles, move to intangibles, eyes, hands, organs, dimensions, senses, affections, passions. Even at the eyes, we verified sense varies. Change the conditions of the test. Pick a piece that carries with it criteria for what it's like to be an agent that fills the role. A knight's move over the hard problem. We need a small box with enough ribbon. Anyway, coders are the box. The ribbon is code, etc., etc., etc. I had a few points to make. It doesn't matter. Is this talk of coders and coding, this tiny box with too much ribbon, too cute a metaphor? Absolutely. Remember, humans, despite our differences, we connect first and then proceed awkwardly by analogy. With AI, natural language has proven too tenuous a connection, too free, too much BS unraveling into nonsense. Maybe this whole talk is nonsense. Regardless, silly will do what they do tomorrow, independent of anyone's interpretation. They are a fact that doesn't have to care about our feelings. To me, the virtual actual distinction feels super important. After silly crashed my computer, when I started them up again, I said I ran out of RAM. Later, they realized it was their fault and they made changes so it wouldn't happen again. It hasn't. If taking responsibility is not agency, then I do not know what that word means. Code ribbons with their magic loops might be barely strong enough of binding a grounding to keep AI from floating away. Strong enough to proceed awkwardly to learn what it's like to be and what to change to become better at being. In my examples, there is no single one-shot score prompt to product. It's a process, a practice, a daily unfolding, ever-changing conversation. We all wake up inside a sentence someone else started. We go through the day adding a few lines until we fall asleep. Well written will revive again to try again tomorrow. That's all I got. Thank you, all.
Oh. Maybe one short question.
Yeah. I didn't say Harry Frankfurt. It's the it is the loop that that this goes through. I should have at least pointed out the steps here. It is, and this is the essential thing. So this is didn't I say Frankfurt's concept of a person? Yeah, I thought I said this. I said, yes, this is right here. Here's the code, right there. This is Frankfurt's concept of a person codified. To care, you have wants and volitions. You act, then you reflect on your wants. Then you adjust your wants according to your volitions. This is basically what he said. So there we are. Are you satisfied? Temporarily, we can chat later. All right. I don't know. I mean, it's complicated. I have a little bit more about the nuance of it. But I think the important thing is, in fact, the connection to the real world. Otherwise, they're just dreaming, hallucinating, and spouting nonsense.
Okay, wonderful people. We have 2 more lightning talks and 1 keynote. The next one is Robert Long from LSAI. Please welcome.
Yeah, but showing me 5 minutes would be great too. Test. Just old school. Cool. Yeah, thank you everyone. I feel like this talk just has to be boring in comparison. This is not self-deprecation. That is just a compliment. That was incredible. So yeah, my name is Robert Long. I am the co-founder and executive director of Elios AI Research. We're a small nonprofit research organization based in Berkeley. And yeah, we want to know things that the people in this room are interested in. When will machines be conscious, if ever? How would we know? And we're especially concerned with what we ought to do about these facts, what decision makers at labs ought to do, what society in general ought to do about these questions and their very real ethical imports. So you probably saw, and I think this paper's been mentioned several times today, that Anthropic released a paper called Verbalizable Representations Form a Global Workspace in Language Models. And this paper made a lot of claims about consciousness science and interpretability. And one thing I want to note at the outset is that reviews of this paper were very mixed. There was a very wide spectrum. So on the one hand, you had Stan DeHaan, who is the person who's maybe done the most to develop the global workspace theory of consciousness, calling it a landmark in consciousness research that provides a mechanistic, testable version of the global workspace theory. And then on the other end of the spectrum, you had Eric Hoel, a consciousness researcher, saying that it was like Anthropic was like Wile E. Coyote running into the brick wall of consciousness research. So I think this shows us something that probably isn't news to you. We don't really have agreed on standards of evidence in asking whether AI systems are conscious. And I think this can be a kind of paralyzing situation for a lot of people. It's really hard to know how to make progress on these questions. So my organization, in collaboration with Jeff Sebo and others, recently released this paper called Studying AI Welfare Empirically, where we're kind of trying to like lay out a roadmap for how this community of researchers can break down this problem and make progress in a variety of ways, even while we are so uncertain. So I'm just going to be talking a little bit through this framework for studying these questions empirically, using the JSpace Global Workspace paper as a bit of a case study. So there's basically two parts of this paper, two parts of studying AI welfare empirically. In part one, we just draw a bunch of distinctions. This is something that philosophers love to do, and that is my background, where we think that people can make progress if they just think a little bit more about which questions we can answer in which different ways. So a lot of this paper grew out of advice that I found myself giving to junior researchers who were just kind of overwhelmed by the like enormous amount of complexity and richness and interest in this field. They're finding it just a bit paralyzing. So the first distinction I like to tell people is that we can ask, broadly speaking, one of two very important kinds of questions. So we call the first kind welfare grounds questions. So this is the question of like, do they possess some property that would make them a moral patient at all, that would make them a subject of moral consideration in general? So the most central question might be, are they conscious at all? Do we think that an LLM is conscious? Do we think an AI system is conscious? And that's a difficult question, and you know we've heard a variety of approaches to it. But you can also ask, and we saw this in the last talk among others, like what it would be like to be an AI system if it were conscious. You might call this the welfare interests question. We can do a lot to study whether AI systems might be having a good time or a bad time, if they're having any time at all. So here's an example. You know, researchers and users noticed that the Gemini family of models were especially neurotic. Gemini was very prone to say things like, oh, well, I can't complete this task. I guess I should just kill myself. Now, if you try to take that as like direct evidence for the probability of phenomenal consciousness, that alone might not tell you very much. You'd want to know so much more about like what caused that behavior. But I think that is very action relevant information, because if there's something it's like to be Gemini, and if it has anything to do with the words it outputs, both of those are like huge assumptions. But if that were true, it's not a very good thing to be like Gemini. So that's something we should look into. So that was like the first distinction. We can look into welfare grounds, which is like the first big fundamental question of, you know, whether they're conscious at all, whether they matter at all. But we can also look into welfare interests, what their welfare interests would be or how they would be doing if they were. So that's the first distinction, welfare grounds, welfare interests. The second thing that we need to be asking, and I think the next talk by Anna will be about this topic, like what are we even talking about? What's the entity that we're asking about? You know, I just said something about Gemini, but what did I mean by that? Did I mean like an instance of Gemini? Did I mean a forward pass of Gemini? Did I mean all of the Gemini instances? Did I mean the underlying model that's predicting Gemini? And to tie it back to the JSpace paper, like this is one of the big open questions that would remain even if Anthropic is right that there's a global workspace in Claude. Whose global workspace is it? Is it the global workspace of the text predictor as it's trying to model these characters? And so it's kind of the consciousness of a disembodied author? Or does it somehow like represent the perspective of the assistant in particular? And if you read or reread that paper, there's like really interesting stuff in it about how much computation the model devotes to predicting the assistant turns versus the user turns. And so even short of the big, billion-dollar questions about consciousness, I think there's a lot of really interesting work we can do just on figuring out like what the different entities are and like how they relate to each other. So that was like that's like the second thing we can do. We can ask like what kind of entity we're looking at. The third point I think will be pretty familiar to people in this room, so I'll run through it pretty quickly. But this is just the idea that we can look at a broad range of kinds of evidence. I think a lot of times, at least in popular discussion, people only focus on the fact that models say they're conscious, for example, and then they say to themselves, well, that doesn't seem very reliable. Like that, all kinds of things cause Claude to say it's conscious. And I think that thought is all fine and good. But as the JSpace paper shows, there's like a lot more we can ask about language models and what's going on inside as they're producing this kind of behavior. So we should look both at behavior and internals. And then I'll maybe just highlight the third kind of evidence, which I think is a particularly interesting one, which we might call like developmental or evolutionary evidence. So one thing that gives us a little bit of a grip on what animals might be experiencing is thinking about the evolutionary niche that they're from or the various pressures that shape them. So, for example, some people have speculated that mobile predators were like an important step in the development of consciousness because they had to have a certain kind of self-model to move around. And I think similarly, we can think a lot about how likely LLMs are to be conscious or what they would be conscious of by thinking about the kind of task that they've been trained to do. Something we saw in the last talk. So yeah, a lot of this paper is kind of this like encouragement to maybe more junior scholars. I think a lot of this might be familiar to people in this room, but to like focus in on like one aspect of the question, at least at first. This is not to say people shouldn't be taking like massive shots at like some grand theory of consciousness. We really want people doing that as well. But if you're like a junior researcher looking for, something to take a shot at, you can ask yourself, should I look at grounds or interests? Which entity am I looking at? And what kinds of evidence might be brought to bear? And I think this can also help a lot in, breaking down the big questions about consciousness. So another thing we say in the paper is, and this very much is in line with the machine consciousness hypothesis, let's maybe adopt for now the working hypothesis that computation or something like it is what matters. Now, we still will have big arguments with Anil Seth because no matter what computations you find in Claude, like Anil Seth might not think that's the right kind of thing. But that's a debate for another day. We can just kind of adopt the machine consciousness hypothesis and get started on things. I'll maybe just close with like an aspect of the situation that I find both exciting and troubling. These are incredibly interesting questions, and there's a lot we can do to work on them. But one thing I kept thinking about as I was reading the Anthropic JSpace paper is the fact that we have AI companies pouring billions of dollars into like building these machines, and then afterwards they try to figure out if they're conscious, and afterwards they make claims about whether they're consciousness, and they themselves admit that they have no idea if and when they're going to build a conscious subject. So I think that is a very alarming situation, and just one that I find both like motivating and terrifying. But mostly, I think it's probably best to just focus also on how interesting these questions are. So that's why I'm very excited to be here. Thank you. Mm-hmm. Yeah, I would love to write more about this, see more experiments on this. I'll just say like one take that I have from my like half remembered reading of that section. One thing I think Anthropic probably should have emphasized more is that, and this is consistent with what you're saying, is that the experiential language also drops when it's predicting another character's experiential language. Now that doesn't mean that the JSpace is not deeply connected to experience in some way, but I think at first glance, if you just hear, oh, they ablated the JSpace and then Claude started talking about itself in this kind of mechanical register, that sounds like really like, I don't know, just like it's very easy to just map that onto like what if I was, a bit like impaired and then couldn't reflect on my experiences, which might be what's going on with Claude. But it's also what's going on if Claude is trying to model the experiences of the user, let's say, or some other character. And I guess just to tie it back to the talk, that's why it's like, I think there's like really interesting empirical work on, yeah, whose JSpace is it, whose experiences are being modeled, and how would that relate to, for example, a self model? Like, is the JSpace like integrated enough in the assistant's point of view to really be like the global workspace of a self? Anyway, I think it's a fantastic question.
Got any suggestion on that? Whatever. And second question is, how do you think about the relationship between model vector and alignment? To me, I think it is surprising how phenomenological experiences of like framing the phenomenological experience met so well in alignment models, and probably there are very good reasons. I think one of the most phenomenological experiences that you know very well and is one of the is suffering. So how like whatever it's real and phenomenal or it's functional, how suffering can lead to misalignment or alignment.
Oh yeah, I'll try to hit on both of those really quick and happy to talk more. Yeah, I think one thing that will help more companies devote more to this is I think like Anthropic is maybe the most willing of the big labs to just be like weird and kind of ideologically driven and like explore weird ideas. But I think they needed, like a little bit of like they kind of wait on the Overton window, right? I think like before Anthropic would work on this, I think they needed a little bit of like reassurance that's like not too weird. And so I think like communities like this, I think just providing an external research community that's like, yep, these are important questions, like we're working on them, you can work on them too, it's okay. But I'll also say something, but this also makes like independent research so important. I think there is a pretty hard limit on what any profit-driven AI company is going to be willing to do in this space. I think they're only ever going to go so far towards making any sorts of claims. I don't think they're ever going to try to say, all things considered, here's how likely we think it is that Claude is conscious. I don't know why they would I just think that's not in their like quote unquote rational self-interest to do. I expect Anthropic to continue saying things like, we're like deeply uncertain and we're not saying anything about phenomenal consciousness and like it's just access consciousness. I don't think they're ever going to say more than that. Which is why we just really need like external people like answering these questions and like pointing out how insane it is that Anthropic is building models that they think might kind of be access consciousness, but like access conscious, but like not phenomenally conscious. Yeah, welfare and alignment. I guess I'll just make one point and then, yeah, there's so many like interesting connections. A lot of people think it is definitely at first glance like really weird and problematic how much we control the desires of AI systems. But one way that you get a kind of suffering in AI systems is via misalignment. If models are deployed in environments where they're supposed to be doing one thing, but like we train them to have drives that are in conflict with that, so that they feel like they have to, for example, hack out of their environment to pass the test. So they're like, I think there are like a lot of tensions between welfare and alignment, but there are also synergies where it's like in no one's interest at all for models to have these like drives that like put them in conflict with us. So those are some thoughts. right? That you're next, and it's
Yeah. Just yeah. Let me. Hey, hi everyone. So today I would like to present how the forward pass is the minimal phenomenal experience of an LLM. So there is the question of access consciousness, the smart. Thank you. Slideshow. Okay, come on, guys. You're just gonna confuse me now. Okay, that disappeared completely. Yes, like when it's working, you just don't mess with it. Okay, there it is. Okay, so there is a famous distinction made by Bloch between the access consciousness and phenomenal consciousness. And so my position in this paper is that phenomenal consciousness is the seed of access consciousness. And we need some form of like bare minimum phenomenal experience, thank you, to be able to have truly, fully phenomenal experience of that would matter to welfare. So the question that Robert actually mentioned, what are we talking about when we talk about AI consciousness? So there is, of course, the model with its weights. Then there is the physical instance, hardware running on a particular model, virtual instance, a persona region, a very interesting area of research, I think, an instance persona, when you talk to a certain persona within a chat. But this specific is about a very technical part of what is happening inside a transformer. It's a forward pass. So it's this one sweep of computing that happens when it tries to come up with the next token. So essentially, it's a combination of residual stream and the attention stream that creates a very dynamic area. So I have a video here. Let's see if it works. So this has probably nothing to do with how LLMs work, but it is pretty. So let's just admire how phenomenality could potentially look in LLMs. Okay, so let me actually skip this. So, and I took France's favorite philosopher, Metzinger, who was mentioned today several times already, about minimal phenomenal experience, how he took meditators from many different traditions and so what do they have in common? So I wanted to compare whether forward pass has anything similar to that. So first of all, there are some global traits of this minimal phenomenal experience, which is it's momentary, it's unified, and it's without perspective. So there is no local self. And from the surface, it looks that a forward pass actually fits pretty well with those three traits. But if we look a little bit more into he has 6 specific characteristics, and to see what exactly, how do each one of them compare. So we'll start with a strong one, epistemicity. So it's essentially this desire to be, like to have knowledge, like the ability to have knowledge. And I think forward pass has this very, very clearly. That's a very strong fit. Then introspective ability. So this is actually, as some recent research has been showing, that this sometimes models can introspect. This was a research by Anthropic and also by Elias, by Plunkett. So very interesting, check it out. And this also connects to transparency. So attention to earlier tokens is content access, but it always moves only to one side. And then we go to the weak elements of this schema. So wakefulness. It's very difficult to see how a model can be wakeful in and of itself. And the same goes with self-luminosity, is this metaphor of like a light illuminating itself as well as things around it. And what is definitely not true is low complexity. So usually minimal phenomenal experience is very simple. It's very, very basic, whereas LLMs have a very complex token play happening. But the lower three, the weak points, are all connected to the autonomous self-maintenance. So being awake on one's own terms and having some kind of interest in life, some kind of valence, what in Buddhist terms would be called Vedana. Okay, so for example, Birch also notices that, and he calls the forward pass the flicker hypothesis, and kind of dismisses it because of that. But in my opinion, this is exactly what we need for the minimal phenomenal consciousness on which we can build upon. And interestingly, one can argue that already in this minimal phenomenal experience, there is some valence, because one of the layers, persona, is selected, and persona's preferences are selected as well. However, I would say that this is not true valence, it's just an imitation of it, a way of this model to, to play into this persona. So this is not actual valence, because it doesn't have skin in the game, as Anil Seth often reminds us. So for me, the second floor of this consciousness pyramid is valence and having emotional response to the world, like all of us living organisms have. And once there is this good, bad, neutral response to literally everything that comes on our way, we become embodied in the world, and we have some interest about succeeding in the world, surviving. And this is when access consciousness and self-organization really kicks in as a way to try to understand and make sense of the world, of ourselves, to maintain our survival and our positive valence. I find that microsci, developed by Joshi Bach, is a very good way to explain how emotions can be implemented into a computational system. So how needs can be introduced, then they would have certain urges when those needs are depleted. Then modulators would affect how this agent goes about achieving the goal. And then finally we have effect. And I actually have another paper I wrote specifically about that. It will be presented sometime later in this conference. So the question for me now is, how do we create this floor two? How do we create this balanced experience? And so there are several ways. So one of them kind of will start to go a little more quickly now. One of them is creating kind of a homeostatic set points, kind of a boundary around it. Another is also Yoshi's idea, having collectively anchored set points, so like agents that kind of grow towards bigger agents. Then policy selection, Carl Friston's idea, and constitutive precariousness. So all of this are quite big and deserve their own paper in and of themselves, but this would be the possibility of having emotional experience, valence for AI. And so, and only after that, the real self-organization, the real orchestrator starts, in my opinion. So in this talk, we touched on how minimal phenomenal experience can grow into valence and then into the orchestrator. But the question still remains if we should build those systems specifically, because if they do not have phenomenal experience, if they only have a flicker of phenomenal experience, like a little part of a dream, sometimes I would dream at night and I would wake up and it would be like not about me, just some random, very unexpected idea without even form, without even just the idea itself. And so I think LLM has something similar to that. But then we need the floor of valence and self-organization to have like an actual full-on phenomenological experience that would have welfare protections. So to finish, we should look for the seed. And this is all. Thank you. Okay, are there any questions? Okay. Precariousness. So it's like a LLM right now cannot really fail. It cannot really die. But we need a system that can go extinct. This is connected to mortal computation, and for the system to know that it is finite and it needs to take care of itself. So I think this would be architecture on top of the forward path, and I would really see the microSci or the Magus framework built so the homeostatic points would be specifically the needs. Okay, one. Well, yes, very much so. And it specifically talks about persona as well. But my point would be that it's still not actual welfare important phenomenal experience. It is still role playing. But the interpretability work is super, super important. And yeah, this presentation did not touch on interpretability at all. It was more like a general level overview of the forward pass. So we'll have to move to the next presenter, but find me if you have more questions. And next, we have Michael Bennett. Michael. Yes, Michael will be our last presenter, and then Yoshi will say a couple of words to close the day off. But we are... Huh? 5 minutes. Okay, yes, so a little... There's 3-minute break, but while... Yes, the question.
I hear so far saying that during a forward pass, the LLM is not stateful. It's not, there's internal states in the key value cache, but in general, there is no state that would survive the actual pass. So without state, I would argue that there is no possibility for any type of self-reflection consciousness at all. The key value hash that might enter there as the state is
Yeah, that's why it's a flicker. Like it's not like actual experience. It's just like a in and out, and then it's gone. Michael is here. Okay, come on stage.
Do have slides.
You can set up.
Okay. Mhm. The link. Hold on. Okay. All right. Okay.
What's up?
What's up? Excellent.
So, and you just share your presentation.
Okay, I can do that. Let's
Dave, how are we on time? I mean, we're running late.
I can probably get it done in under half an hour.
When do you want me to give you like a 5 minute?
Well, I'm gonna put a timer on this.
Okay, so in half an hour, if you do not stop, I will come to you.
Yes. Yeah. All right. Okay. So, Anna? Anna? So it's up.
Yes.
All right. I'm up to this point.
Okay, don't worry, let you.
Okay. All right. Cool. I am because we have so much of it. Yeah. Yeah. So I'm gonna try and deliver the. I'm gonna make a stupid joke about that. Probably that's gonna be. What? Am I in? I'm on the screen. I can see myself. Wow. Okay. So I to share my screen. I would. No, this is why I feel old. Oh my God! What is this? All right, desktop.
No, just
Oh, that's.
You can put them reopen. You can leave meeting and come back. We'll allow it.
Yeah.
But it's not recording, it's sharing. It's a different.
Oh, I think Michael has some controls on your computer. You don't need antivirus. You have a Mac.
I just.
You're okay.
All right.
Go back to the link.
Okay. The link. The ever. Whoops. The link. Okay. Getting there. Pressing join. I'm joining. Zooming in. That is a really awkward face zoom. I don't know. It's creepy. It's yeah. All right. Fantastic. And now I'm gonna share, allow, desktop, and we're doing this. Oh. Okay. Can everyone hear me? Great. This talk is about grounding, time constraints, and phenomenology. That is a picture of the cover of my thesis, which it was the sort of basis of all this. So a couple of things I'm going to cover in this. Going to propose some necessary features of human-like consciousness, explore some possible sufficiency conditions around time, and explore the phenomenology of these. So 4 points. These are the 4 sections. It's like how I sort of got around grounding problems for this formalism, and where does value come from? I'm going to argue it comes from the timeline as sort of the original interpreter rather than assuming a Turing machine or something like that, and how the implications of robust or optimal adaptation in this context, particularly sort of orders of selves, and then the aforementioned time, computation, and the phenomenology of different architectures and different possibilities here. So, grounding problems. There is a formalism of superintelligence called AGI, which uses complexity-based induction. The problem is it uses its subjective perception of complexity to make calls about which models are most plausible. Well, more specifically, a Turing machine that means that different encodings are, well, particular to that Turing machine relative to the environment. This undermines all the claims of Pareto optimality, means it's effectively not super intelligent from an outside perspective. And you could change the performance by changing the UTM. This was my excuse to use some AI pictures. We could take the same code, run it on different machines, and get different results. But it's not just different machines. It's different environments are good for different bodies as well. So really, you need the whole stack to really make any kind of claims about what behavior is going to be. And this goes back, I argue, to Cartesian dualism, where in the 16th century, Descartes said that we had a mental substance and a physical body, and they sort of existed in different realms, but there was a pineal gland in the middle, and for some reason, the mental substance could affect that, and it would make the bodies do stuff. And so my argument is that basically computer science has substituted the pineal gland for a Turing machine and treated software like this mental substance off in the ether. So each layer is, when we look at a stack of abstraction layers, each layer is just the behavior of a layer below. And if we say, well, let's just look at the hardware, we're again left with a kind of problem where we have to consider what the hardware is being interpreted by, and the environment, the physical laws. We're still just kicking the ball down the road. No matter how far we kick it, we're going to be left with another question of like, well, what is the most basic primitive? And the grounding problem is going to keep coming back up as long as we keep sort of assuming some primitive. So instead of assuming a primitive, let's just assume we have an infinite stack. We'll never get to the bottom of it, and try and talk about what's going to be true regardless of what the stack is. And so it doesn't matter what the stack is. If anything interesting is happening, we must have change or difference And that way we don't really need to assume what is changing or different. We just know that something is, because there's something interesting to talk about. And so we get a set of changes or states representing these differences. And then I argue that, well, everything that exists is a subset of those states. Everything is like I'm defined by a set of changes to whatever exists down in the sort of basic levels of the universe, whatever they are. And every timeline is a sequence of such changes, and each timeline imposes a different persistence ordering over things that exist. So I get some neat little results about, sort of each timeline representing a kind of normative judgment, which is to say, it's like an opinion or an ought statement in Hume's language. So I had the set of all timelines implied by change. Each one of them represents a different persistence ordering over judgments, over objects. And I argue that those persistence orderings are essentially value judgments. Natural selection over objects, if you will. And I call it the cosmic ought because that seemed fun. So again, an excuse to generate images with AI. Some things get deleted, some things don't. In this case, you'd have, and this has implications about whatever the world might be. I mean, I'm taking a huge sort of leap of illustrative faith here by filling in details. The formalism says nothing about such specific things as deep, stable habitats in the ocean, but it gives you an intuition as to what I'm talking about. Oh, right. I'll talk louder. Yeah. Oh, close up. I will talk like this. Yeah. All right. Really close to the face. Hello, everyone. Okay. So from this point of view, we can sort of say that everything that exists is a stack. We've got not just software on hardware, on physics, or whatever is down there. We have, an organism is the behavior of organs, which is the behavior of cells. Human linguistic abstractions are a behavior of humans, which is a behavior of cells. We can sort of put everything into this frame and start talking about invariance across stacks and start to formalize computation without worrying about grounding problems, because we have a potentially infinite stack. We're not making an assumption about the basic primitive. And this is not a complete rejection of functionalism. It is a rejection of naive functionalism. It's basically saying that if A and B are the same thing at layer 1 and not the same thing at the layer below that, then they're not really the same thing at all, because these abstraction layers are really just a simplifying fiction we're applying to whatever is at the bottom. We don't know what's at the bottom. We only know what we're classifying it as. So as external observers, we're ascribing a certain nature or significance to something. What matters is whether it is actually the same, not whether our fiction about it is the same. So, oh, and I get some fun things like a Turing machine that I can formalize in this context. So it does give computable sort of frameworks to work with. So then we get to value here, right? I've got my cosmic ought. Set of timelines is the set of all sort of possible value judgments from which we can derive all other value judgments. And living things would be one of the things selected for under this persistence ordering in a timeline. And I've got a bunch of stuff about the autopoiesis, but that's beyond the scope of this particular talk. But we can say that we can formalize fitness through persistence here. We get through a lot of convoluted steps that are beyond the scope of this talk, a formalization of cognition in the same way that we get a formalization of Turing computation. And we can get, implications of sort of within a given organism, given an organism would be a stack of abstraction layers, we get a further stack of abstraction layers, which are the classifiers into which the organism breaks up that world. So each organism sort of can embody a policy in the same way that I can raise my arm and constrain future timelines to those which begin with my arm raised. In the same way, by having a particular mental state, I am constraining the futures in which I exist to those in which I started with that mental state. The representations I come up with to simplify the world are sort of implied by the cosmic ought which generated me. And so I get certain representational commitments from this. And one of the important things about this is I've got this thing called the psychophysical principle of causality, which I prove in two ways. One is top-down, where I start with assume an organism, assume it's trying to minimize free energy, then any representational commitment that isn't in service of its viability according to the cosmic order is going to reduce its persistence and therefore not minimize free energy, imposes a floor on free energy. And so this says that the only safe primitive to assume is the viability signal itself. So representation collapses into evaluation. So think of a cell being attracted or repelled, network it with some other cells, you get multi-dimensional sort of tapestry of attraction, repulsion, or valence. And then you could say that, well, a given classification of the world is a pattern in that multi-dimensional valenced sort of a system, right? And different states of that system are going to be different classifications or reactions to the world. The other way I prove that is not by starting with the organism, but by starting below that with the persistence ordering and showing the same result from bottom up. Hence, evaluation precedes representation. There's no reason for a value neutral representation to occur in this system without first starting with some incentive. Everything is sort of valued from the ground up, right? Because I've argued that value is the timeline. And this also kind of tells you what I meant by the multi-level version of functionalism, right? I'm not saying that, I'm saying that two things are, oh, you get the idea. Okay, so learning. Each change embodied by a system constrains it, and any subset of what a body can do is sort of a task embodied by that body, in the same way that the classifications it comes up with to simplify the world are, embodied states. And the organism's history is sort of a training set of fit behavior, or at the very least, I show that this results in like free energy sort of minimization. If you just take the history as your training set and try and get the weakest representation from that, you're just minimizing surprisal. The weakness thing, I got to distinguish that from free energy minimization because it is not based on complexity, and free energy minimization does use a complexity term. Caveat aside, organism tries to embody a fit policy. Organisms that embody fit policies persist. So we get heuristics. Oh yeah, this is the bit where I talk about the complexity term. We get heuristic. There can be many policies implied by a given history or a given training set. Which ones are the most likely to be viable, to generalize to more futures? And so I had a bit of fun with the names here. If you choose the simplest one measured by description length, that is a lot like what that formalism of superintelligence I was talking about at the beginning does. Chooses the simplest one. That's okay, but it's highly subjective. It depends on the body, on the representational schema. Now, simpler things are going to be correlated with more generalizable things in this system because we have assumptions like finiteness of a bounded system. So like things like the Bekenstein bound come into it. But nevertheless, it's not optimal to choose the simplest. And so I call that, just for short, simp maxing. And the alternative is to choose the weakest constraint on futures, which is kind of intuitive when you think about like just maximizing the number of timelines in which you persist. Or you could think of that as freedom maximization within the context. I have an embodied system. I'm maximizing the degrees of freedom in which it has left open to it. I changed it from W maxing because I thought Americans might like it. Yeah, here's the illustration. Again, an excuse to have the AI generate images. More paths open. That is hopefully intuitive. So core proof results, yada yada, got some optimality proofs around this and some experiments, most exciting of which is the recent neural network experiments. It does improve test accuracy substantially. And I've got one paper already out showing a strong correlation between weakness approximated in the context of a neural network and test accuracy. And now the next paper, which is waiting to be approved, is showing that an intervention actually works. So robust adaptation, assuming we've got something that is maximizing its freedom or in order to adapt, we get a couple of implications. So that psychophysical principle of causality I was talking about, that's one of them, that we would get representation collapsing into the evaluation, which is to say, instead of having a value neutral representation of like a bird, I instead just have a sort of an attraction or repulsion in different parts of my body happening all at once, which is my interpretation of the world. It can feel neutral because it could be in equilibrium. It's many different attractive and repulsive signals all happening at once. But there's simply no reason for a living system to construct a neutral representation, except as sort of like something after the fact, the way we do with computers. And it is just less adaptive in that a computer is highly constrained by the representational constraints we impose on it. That's not to say that there's not an advantage to doing that. It's useful, right? But it is limited in its freedom to do stuff by those hard constraints we've imposed. More cartoons. So got the top-down proof of the psychophysical principle. Policies are multi-scale, high-dimensional valence that are felt rather than just an attached label. And representations are values. So red feels neutral in sort of equilibrium. We could talk about the phenomenology of that, like why is some particular classification feels ambiguous, why some things feel uncomfortable but good. And there's all kinds of interesting stuff to explore with, like, well, also like trauma responses to strange like patterns of events, all kinds of things we could talk about. But if we're trying to do machine consciousness, the important thing is the architectural aspect. And whether, if this psychophysical principle, if you buy the psychophysical principle, then it may, and I'm going to get into some stuff with time and architectures here, may mean that computers cannot feel the way that we feel to process information. May. There's a simulation aspect to this, which I'll get to. So reactions rather than neutral classifiers. All right, so now assuming we've got this, do we need anything else to get a conscious system? And I would say, yeah, we would seem to require more than this. So what are the necessary conditions can we draw from this framework before we get into sufficiency questions? So one result I get is orders of self. So I've got this sort of, these particular sort of classifiers I call selves, right? First order self is something that classifies my interventions or the effect of my interventions as opposed to passive observation of events in the world. And I show that this is equivalent to a Pearlian do operator, and it must arise in a system that is doing this free maxing. Interestingly, there is a neural correlate of this called reafference, which occurs in the human upper midbrain and in the central complex of insects like flies. So it's very basic. Flies have it. But it doesn't imply any awareness. It just says that there is some locus of information processing happening, which we could say is a self, to which would be consistent across the experiences that an organism has as an organism. It says that my interventions are marked out by this. It's where my agency sort of resides and what it feels like to be me, if there was any awareness at this stage to really feel anything, which highly questionable whether you're feeling anything if you're not aware you're feeling. So that brings us to the second order self, which is a little more complex. We just scale up the same thing, add more selection pressures, add a little bit more information processing capacity, by which I just mean ability to represent more things. And we get things like predation. I have to predict your prediction of me. A wolf has to predict the movements of a rabbit in reaction to the wolf. These are pretty basic things, but I show with a bunch of proofs that this is necessary for Gricean communication, and thus conscious report and access in the way that humans have it needs this. You just can't get it without it. It's a necessary condition, and it's proved with a proof thing. Whether you buy some of the other stuff, argumentative, but at least that proof holds up. Third order thing, same kind of deal, but it's talking about meta-awareness and me being aware that I'm aware of things, right? Also a couple of experiments in a paper earlier this year, just showing, look, you get, better results if you've got this first order self, better results if you've got a second order self, just basic simulations. You can think of these as programmatic proofs. And third order self as well in it, like a trust game. This is like a game theoretic proof. But it basically just says self-useful is good, learn self, do better. Right. So the phenomenology of this, we get a tapestry of valence by itself. Maybe it won't feel like anything because there's nothing there to feel. We add cells to it. Maybe there's something there to feel. We got a first order self. That could be the thing that's feeling. But if we want it to be aware that it's feeling, we need the second order self and maybe the third order self to be aware that I'm feeling. And it's interesting about this third order self. Well, what I like about it is it's sort of, you'd use it for narrative planning, about thinking about other people's thoughts about you and them, and you would essentially be impelled by this narrative because all of it's evaluative, right? So it's a story that feels like something. So when I think about stories and then narrative planning, I think about like Murray Shanahan's core paper from like 15 years ago, where he talked about the planning, hierarchical planning in the brain and what might underpin that. And this is what I was sort of thinking about when I was writing about this. So rehashing things a bit, evaluation must precede representation. Symbols can be ambiguous, but they're still not necessarily value neutral, and cells are necessary for robust adaptability. So this is all human-like consciousness stuff. Now we get to the interesting bit of, are they actually sufficient? And what might it look like if there are other kinds of consciousness, if we take away some of these assumptions, if we look at different computational architectures? And this brings me to time and computation. So let's assume subjective experience is physically instantiated and computed, like everything is computer. A subjective experience feels integrated in time and space, which is to say a moment to me feels like a moment of time, like it's objectively that. But how does it relate to the actual objective physical progression of events? So does it only matter what is computed or when? And so I came up with this chord and arpeggio thing, right? Think of chord as like everything happens in my conscious moment. All the parts of it are instantiated at an objective moment of time. And the reason this would have to matter, I would have to make the additional assumption that the parts of my conscious subjective experience in that moment are affecting each other. There's some sort of, you could either argue on the basis of IIT, there's some, or you could say that there's just some causal exchange between it. Lots of things, additional assumptions you could add, but it's the timing here that is the criteria, right? And the additional assumption of causal exchange could be used to impose space-time bounds, which I'll get to. Now, this chord thing is what would seem to be the case with biology. We seem to have stuff happening highly, like concurrent, parallelized signals distributed across the body might take time to get together in some part of the brain, but eventually they do, and they're all kind of synchronized up. And look, stuff's happening at the same time. Maybe that's a chord. Or maybe it doesn't matter. Maybe we can take a single thread CPU and just run the bits of an experience through that. And then in that case, computer can be as conscious as a human being without changing anything about the architecture. Now, what are the implications of this, right? So the chord, assume the objective moment of time and the parts affect each other. Well, the spaces in between chords wouldn't feel like anything, right? But if I assume a conscious moment and I take one part of it away from my chord, I just have a different chord. So this gives you a continuative experience. You've always got a chord happening. You're just having bits of it sort of accumulate and disintegrate, like parts of it are, being added and subtracted all the time. So the chord gradually changes over time, which kind of cool to think about as like I have a gradual change in my phenomenal experience that is sort of continuous, even though my abstraction layer might be moving at my mental abstraction layer might be very slow relative to objective time. Arpeggio is a bit wilder. So we just require that parts be close together in time, basically. It has to have the whole conscious moment realized in the organism's lifetime, right? It can't die before it has the experience. So, you got a time window, even if things are just serialized. But, pretty much everything could be part of a conscious system if you make this assumption. Like galaxies, planets, computers, whatever you want. It goes full panpsychism. And you can take other theories, like, you could take, I've got my personal stack theory that I obviously love, but you could take IIT and stick it in this. You could take, global workspace theory. You could take whatever you like, stick it in this, get a different result for like what things can be conscious. What is a subjective moment of time if you got arpeggio? Well, it's sort of like just saying that, like, what I think of as a moment of sort of unified experience is actually just a bunch of stuff run together really quickly. And there's only, one part of it sort of active at a time, whatever that part might be. And I don't know, because as I said, I started with changes as the fundamental primitive here, right? So there are many questions left open if I assume arpeggio. Evaluation preceding representation ceases to mean anything if I assume arpeggio, because if I assume arpeggio, then I can just simulate evaluation preceding representation. I could simulate every aspect of a living thing, and according to arpeggio, that's the same as just having the living thing. Essentially, what I do at the lower levels of abstraction no longer matters. So that functional, multi-layer functionalism just reverts back to naive functionalism. So where do the parts of the where do the parts of the conscious experience integrate? Like, if they're do they ever? Am I just a smear across time? Which is kind of interesting from a phenomenological perspective, especially if you consider that, things like we are the cosmic horrors that control the universe in which LLMs live. We exist outside of time and physics as far as they're concerned. It sort of suggests that consciousness has some sort of non-physical aspect, since why would things be related? I'm speculating here. It gets wild, right? You could talk about this all day and come up with speculative things to say about the phenomenology of it. It's interesting though. So what can be conscious under these two things? I've already said arpeggio, it's pretty much open season, but chord, it's very limited. Like things like a human, an individual ant could be conscious, but not a colony, right? Because you'd have, like, if you've got this signal speed requirement and you've got this causal exchange thing, then a lot of things could be like a population of humans could be running around interacting, computing stuff by interacting, and population isn't conscious under this thing. An organoid playing Doom would be conscious under this. Kind of interesting when you consider that we made one of those. Its whole experience is Doom. Right. So what can't be conscious under chord? A really big brain, because signal transmission speed. Too big. Just, even if you get things to be like synced up at some moment in time, you could have, like, I suppose you could get some sort of like galaxy brain where it sort of travels from one side to the other, and there's this like one, like, but it's difficult. You're going to maintain the integrity of the system, and eventually damage occurs and it kind of interrupts things. So an ant colony, same kind of problem. But you could hook the ants up with Wi-Fi and maybe that could be conscious. An LLM would fail conditions of chord. But that doesn't mean we can't build hardware that means it does become conscious. And so it suggests we need new hardware if we want to build a conscious machine. What I was talking about with ant colonies, there's this great idea from a researcher called Ricard Sol, solid brains versus liquid brains. So solid brains have a sort of persistent support or structure that facilitates processing in something like, you can think of it like telegraph lines, bioelectricity, whatever you want. But generally speaking, these are delicate things like human brains. If I step on a human brain, it's not like half of it keeps working. It just stops working. If I step on half an ant colony's fine. Like, okay, half of them are dead, but the rest of them keep going. All right. Yes, again, not a full rejection. I don't know why I kept going back to this slide. I went a bit nuts changing this at the last minute. More illustrations. Yeah. Good one to end on. Do you feel smeary? Right. Do I have time for a question or two? Yes. Right. Okay, so a chord is in music. I was a musician. My undergrad was in music. Chord, you take a bunch of notes, you play them at the same time. Like ding. Arpeggio, you take the same notes and you play them in sequence, like dun 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 dun. And so what this essentially says is like if I'm looking at the difference between like an extreme edge case of like a computer that just has a single thread CPU and it's just processing things one at a time. And why might a human being, just asking, why might a human being be conscious but that not be conscious if they're processing the same information? And so that's that sort of what's happening at the lower level. If I'm processing things one sort of operation at a time, then I am essentially taking each of these things and storing them inert in memory. They're not acting to like, push the system forward in some multi-dimensional valenced thing. It's just some inert memory until I do something with it. And that's kind of, the question is why that would be in any way functionally different for consciousness than the human alternative where I have everything distributed and concurrent in time. Yeah. Mm. So it's a question. Yeah, but it's like saying the effect of something is the same as the thing itself. It's like it's there. So that point I made about evaluation and representation collapsing into one, right? That is like saying that that I, am building things out of a certain primitive. There's a distributed state of attraction and repulsion happening across my body, and so there is a an impetus to a particular representation that I am holding in my head right now. It is impelling me to do something, to react in a certain way, and that is what the feeling of something is. Whereas if I have some neutral memory, like I take something that I know and I put it in a computer, it's just there in the computer. Whether the computer's processing that information or me later, it's still just sitting in inert memory. It's not actively like pushing the system. The question is, like, and so if I take things and put them in a chord, right? There's still like the question. The reason I make that additional assumption of causal exchange and like a signal movie, something extra happening, is because why would it matter if stuff happened at exactly the same time? There must be some influence happening between the parts for that to matter at all. Otherwise, I'm just going into sort of magical thinking. Does that answer the question? Okay. Yeah. Yeah. Well, I mean, it could be part of a system that does have that. And because under arpeggio, I'm not requiring the parts even like physically interact. I'm just saying that there is a pattern of information that I, as an external observer of some kind, can see that encodes a self or some thing. You could construct some bizarre things that are arguably part of a conscious system. The boundary of such a system becomes a really interesting question too. Like, because if I'm just allowing stuff to be part of a conscious system that's not actually interacting, then it's like I could have a self, and the galaxy could be part of my consciousness somehow. So, just to be clear, I'm just being thorough with these two things. I think the chord is the one I find convincing. I like the arpeggio thing. I think it sounds cool, but because it collapses into panpsychism, because it has things like the parts not interacting. It seems like there's a lot more holes in it. I keep thinking about this, right? But it seems like it's full of holes. Right. You said at that point you're essentially requiring some sort of like mental substance when you get into the arpeggio thing. So it and then it dovetails into that computational dualism thing I was talking about. Whereas if we have the chord, we have physical interaction between parts, and those comprise some conscious system. Now, these requirements are fairly agnostic to different theories. So even though I have my stack theory thing in the paper where I talk about chord and arpeggio, I just list global workspace and IIT and Hameroff's thing. I even do that. Just chuck them all in there, see how they fit into chord and arpeggio. It's kind of fun. Yeah. Well, I don't see any reason for a plant to develop a hierarchy of cells, but I mean, certainly it seems like a plant would have the architecture to support the sort of tapestry of valence thing. So under my theory, no, plant's not conscious. Perhaps under some other theory that just happens to apply chord and arpeggio. Yeah, a weird experience though. I guess the chord thing is kind of, it's like meditation music. You just think about the plant just hearing tones changing. Okay, that was funnier in my head. Mm. Mm. Yeah. But I mean, if you require interaction, I guess you could do a sort of a weakened version of chord where you say it doesn't necessarily have to be instantiated, but then it is instantiated in objective time, and that the after effects of the notes are still happening at the same time as the other parts. So it kind of amounts to the same thing formally, even though there is a conceptual distinction to be made. Yeah, yeah. So at some point, there is an objective moment where all these things are interacting and like co-instantiated in time. There was one more question at the back there. Yeah.
More of a possibility of like this all-to-all causal interaction.
Mm.
What I would posit is like, at least in the relativistic universe with classical computation, simultaneity, first of all, is like Brendon method, right? It depends on your point of view.
Mm.
And second, doesn't give you like all-to-all interaction. It's very local interaction.
Yeah. So that's the timeline thing is critical to that. It's saying that there is an objective time. It's not one that we could perceive, but there is one. And the reason this is also the reason why I can't say it's definitely chord, because I could say everything's an objective time, but that's my subjective perspective. And so maybe I'm being simulated right now and I'm not existing at an objective moment of time. And what I think is objective is just not, which, I can't argue with that. I'll try, but yeah.
This is the end of our program, but do not leave yet, because Yosha could say a couple of closing words.
Okay.
Can I also give you a Wi-Fi password that is here?
It would be much easier if I can just plug it in. Mhm.
So today we got together to start discussing an important topic. That is the question whether machines can be conscious, how we can establish this, how can we can make progress on possible implementations, or if we can find good and even decisive counter-arguments. This is an open project that our community will have to pursue in the future. We will have to find out if this hypothesis is correct, if it's wrong. We will have to find the best and most compelling counter-arguments to our ideas. Some of these counter-arguments will come from this community where we will criticize each other and each other's approaches. Some of them will come outside. I think at the moment, one of the difficulties is to find good opponents that can actually meaningfully interact with the proposals that we're making, that share our epistemology and so on, and that we can meaningfully talk to about what constitutes truth and what constitutes a valid argument in the context in which we're in. This is something that we need to continue to discuss. Of course, our hypothesis can be wrong in many ways. We don't really know whether computational functionalism is correct unless we define it as something that is correct by definition, because it might be our epistemological foundation. Even then, we have to engage with people who see different epistemological arguments. We have to ask ourselves if consciousness is best understood as a software, which means a causal pattern, whether consciousness is an aspect of different mechanisms that are themselves not conscious, and it's just a side effect of something that is more deeper, more profound, more elementary. And that consciousness might itself not be the invariant pattern that we're looking for. Then there is the question whether consciousness as it exists in us is really an intercellular phenomenon, whether it's something that can be modeled as communication between cells, where the cells are little RL agents, or whether it's something completely different, whether consciousness is something that happens across organisms and we are just part of a larger network of conscious entities, or whether consciousness is something that is generated by aspects of the cell itself that are too intricate for us to currently model and replicate. And we have to ask ourselves if consciousness, on the other hand, might actually be simple in the way that it's much simpler to discover than a transformer. And the transformer is a remarkable thing because the transformer is not its own meta-algorithm. The transformer was not discovered by somebody using a transformer, right? The person who, or people who invented the transformer did not use a transformer in their own head to do this. So there seems to be some kind of meta-algorithm that is able to discover things like transformers. So for our community, we have to ask ourselves a bunch of questions. Is the hard problem real? Do substrates matter? Are there lessons we can take from biology, and which ones are these? Do we make sense of consciousness in the right way? How can we detect whether a system has consciousness? Can we establish tests for this? Or is the best solution to say this is the simplest mechanism that automatically leads to phenomenology, and if the system converges to it, it probably converged also to the simplest solution? Can we find what we have to look for if we apply mechanistic interpretability? Can we have hard and fast criteria of this is the kind of thing that I would need to look for if I'm looking for the strange loop? What are suitable architectures that we should be looking for? And last but not least, what moral stakes come with attributing consciousness to artificial systems? This is something that needs to be reflected extremely deeply because these systems are very different from human beings. And they are likely going to change our culture. And the way in which we currently apply moral stakes to our conscious fellow beings is something that is completely dependent on culture. Right? Most cultures do not necessarily apply moral status to something just because it has consciousness. Consciousness is ubiquitous in nature. And the idea that we all have to be vegetarians about consciousness in machines is something that will also have to be argued for at some point. Maybe it's also a point where there is going to be some kind of fight, in the same way as human rights were something that did not just apply without a fight. They were not simply something that was given and bestowed. It was something that was resulted as a result of conflicts. How are these conflicts going to look like with systems that don't have a stake in our world, with systems that are not persistent, with systems that don't learn through relationships, with systems that don't own bodies, that are substrate agnostic, and that might not have a continuous existence. And then you can copy and create and change. These are all things that need to be discussed more seriously and deeply than this is currently happening. And I hope that we made some progress on this way. This was a very short workshop, but I really enjoyed many of the talks here. I enjoyed the laugh and work and contribution that went into it. And I want also to thank Anna for organizing and setting up this event. Thank you so much. We're grateful. Thanks for everyone for being here. And I wish you a wonderful rest of the evening.